Hey there, and welcome to my course on making your first ever mobile game using the Unity game engine integrated with the object-oriented programming language C#. Mobile gaming is a rapidly growing billion-dollar industry, and in 2021 alone, mobile games accounted for 59% of the total gaming industry revenue worldwide. Creating a fun and interactive game can be an incredible source of passive income, and the skills needed to develop games or software in general are in higher demand right now than ever before. If you've made the wise decision to learn how to develop mobile games but don't know where to start, you've come to the right place. In this course, we'll cover all the basics of C# and Unity, which will allow you to make your dream game a reality with absolutely no prior experience required. We'll also cover all of the primary aspects of mobile game development and design, from game loops to menu systems, and game feedback to ad integration. As stated before, we'll be building our game using the Unity game engine integrated with C#, one of the most widely used and intuitive tools for mobile game development worldwide. After completing this course, you'll have built your very first fun-to-play, monetizable game and acquired the skills and knowledge to improve and change the game to make it your own. In addition, you'll have created this platformer game. Building a mobile game can be a tricky task, but with the guidance of an experienced Unity mobile developer, it will be much less intimidating. So what are you waiting for? Invest in yourself to learn the basics of mobile development and start making your very first game. Hey there, and welcome. Now, as mentioned in the previous lesson, the tools we'll be using for our mobile game development journey are Unity and C#, which are two powerful, reliable, and most importantly free tools for game development. To begin this course, you'll need to have Unity installed, as well as a script editor such as Visual Studio to code C# in. The installation process for both of these is rather simple. However, I will briefly go over it to avoid any potential errors that may arise. Firstly, head over to unity.com/download to download the latest version of Unity Hub. Select whichever of the blue download links present on the screen fits your platform and follow the installation process from there. This application will allow you to add, remove, or update various installations of Unity on your device. Then, launch Unity Hub and ensure that the version of Unity you are installing has mobile development checked. I will demonstrate this process by installing the latest version of Unity currently available onto my device by checking Android and iOS build support, accepting the terms and conditions, and clicking yes if a prompt appears. The installation will then begin. Once that's done, head over to visualstudio.microsoft.com/downloads to download Microsoft's very own code editor. Click on the free download button under the community title to install the latest version of Visual Studio. Once that's downloaded and installed, you'll be ready to start developing your very first mobile game. Hey there. In our last lesson, we installed Unity and Visual Studio, and by doing so, set up our development environment. Now, we need to create the project file for our mobile game. To begin, launch Unity Hub and select the blue New button under Projects. Once the creation window pops up, enter a name for your mobile game and select your project's file location. After this, make sure to select the 2D template. Avoid any of the auto-generated mobile templates as we will not be using them for this course. Once you're finished, select Create, and Unity will generate a brand new project for you. This may take some time, so prepare to wait for a while. Once your project has been created and Unity loads up, the first thing we're going to do is make sure that Visual Studio is set as our code editor. At the top of your screen, select Edit, Preferences, and then, once this window pops up, go to External Tools and make sure that the version of Visual Studio which you installed is selected as the external script editor. If it is not, and is not one of the drop-down options, select the Browse option and find and double-click the .exe file from your Visual Studio install location. Before we start getting into the layout of the Unity editor, we're first going to start with a few concepts relevant to our course, which should make everything easier to understand. I'll start with the very basics. Obviously, we're going to be using Unity as our game engine. If this term is unfamiliar, just think of it as a tool we use to simplify some of the aspects of game development. While this does make some of our game development obstacles easier, we will inevitably have to write our own code and logic at some point. We'll be writing this code in Visual Studio, the code editor we installed earlier. This will basically format and color code all of our logic to make it easier to analyze and understand. We'll be writing the actual code in the C# programming language. The basics of all of these tools will be covered extensively in this course, so don't worry if anything sounds unfamiliar. On top of this, there are a few Unity and C# concepts that will be useful to understand before you begin developing your game. A lot of the concepts in C# may be more useful to those who do not know how to develop in any language, so if you have some coding experience, you may be able to skip over a few of the next points. While coding in C# is an incredibly lengthy topic that could not be explained in any short amount of time, a few concepts may be helpful to know before we start developing. We'll begin with procedures. Procedures, usually identifiable throughout this course by the code word void, are areas of our code that we call at certain times to accomplish certain tasks, such as calculating high scores or generating map segments. The other main coding concept we're going to cover before we start is variables. You can think of variables like storage spaces for different kinds of data. The type of data that can be stored is determined by the type of variable. For example, an integer variable will store a number, and a string variable will store text. Now in Unity, there are a few more concepts that may be helpful to understand before we begin. An object is anything in our game that we can assign logic to, such as a character or power-up spawner. When we refer to a sprite, we refer to the art design for a character. In addition, a scene is Unity's way of differentiating between sections of your game, such as the main menu section or the level select section or even different levels in a game. It is, however, possible to create your game in a single scene, and for simplicity's sake, we will be doing so in this tutorial. This is not a problem for us, as our game is not going to be incredibly demanding. If we were making a first-person shooter with incredible graphics, however, using multiple scenes would be advised. Finally, when we refer to assets, we refer to files which we use in our game, such as PNG or MP3 files. Don't worry if this all seems like a bit much, as we will go over this throughout the course. The only thing that needs to be sinking in at the moment are the basic concepts of Unity and C#. Now that we've gone over the basics of our game engine and programming language, let's get started with the layout of the Unity editor. When you launch Unity for the first time, you'll be greeted by this rather intimidating layout. Don't worry if this seems confusing or complicated, as it will become much more familiar with time. In addition, a lot of the features you may see in the editor we won't need in this course. At the very top of the Unity editor is a menu where you can, like many other applications, save your project, load files, access help, etc. We'll get into this menu later, but it's what you're going to be primarily using to navigate Unity. Below this, we have our scene hierarchy. This is a list of all the current objects in our scene. Here is where we'll store everything in our game, from our character to our map components to our visual design objects. With a few more complex exceptions, if an object is not displayed in the scene hierarchy, it will not be influencing our game. Underneath this, we have an assets menu, which is a list of every single file stored in our game's directory. If we want to add a song to our game or a character sprite, we import it into this location in the Unity editor, which then allows us to add it to our game. On the right is the Object Inspector, which allows us to tweak the various properties of objects in our scene. This includes their position in our scene, size, rotation, the logic they have assigned to them, what they look like, etc. Finally, in the center of the editor, we have our scene view. This will allow us to see our game in action, test it, try out visuals, and much more. You can think of it as a preview of what our players will see when they play our game, which allows us to test our project without building it all the time. Now, the location and size of all of these areas in your editor may differ, depending on your window layout. If you're using the default layout like me, yours should look similar, but you can change this layout up as you get more familiar to see what works for you. Again, if this all feels intimidating, do not worry. You don't need to remember everything that we've gone over in this video, but it may be beneficial to watch it again, as you may understand some of the concepts the second time around. This is by no means required, however, as we will cover all of these basics throughout the course when we come across them. Hey there, and welcome back. Now, in the last 3 videos, we've covered the introduction to my course, the basics of Unity and C#, setting up our development environment, all the concepts we need to know, but the time has come now for us to start actually creating our mobile game. Now, if you look at my screen, you'll see that I'm using the default Unity editor layout, and under assets, I have everything that's auto-generated when you make your project, and this course assets folder, which you guys won't have. All this course assets folder is it's all the assets, so currently it's just PNG files, but later on when I add more to my game, it'll also be the MP3s, MP4s if I might need those, anything I'll need for my game. And all of those assets I'm going to link underneath this video under the resources section. So what you need to do is you need to find the resources section of this video, download the course assets zip file, extract the zip file so you just have a normal folder, and you need to put that folder inside the assets folder of your Unity project. And after you've done so, your screen should look exactly like mine under assets. Now our first task in Unity is going to be creating our character. This is not going to be incredibly hard at the moment because we're not going to add any complex logic, we're not going to add any scripts. We're just going to make the character that we're going to use as our main character for the rest of the course. So we're going to do so by going over here to the object hierarchy, right-clicking, and selecting the create empty. Now we're going to name our player. I'm naming him player. And on the right over here, we can see all of the properties this object currently has. So currently it's position on the x-axis, y-axis, and z-axis, which we won't really be using because it's a 2D game. However, I do recommend you always make this 0. Now, what we're going to need to do is we're going to need to select this tool over here, which is the move tool. This, depending on your version of Unity, should be over here. If you have an earlier version, it might be up here, but find the move tool and you're going to have to drag this wherever you want. You can also do so just by changing these values. But obviously we can't see anything yet because this object doesn't have anything assigned to it. So to make it actually our character, we're going to add a sprite renderer, which allows us to add a sprite, which we covered earlier, a PNG file, to this object. So I already typed it in, but for your case, just type in sprite renderer and select this one over here. And you can see over here, this should be all the default settings you have. And there's a sprite over here, which currently has nothing assigned to it. And these little boxes over here is what we're going to assign sprites or audio files, anything to when we're adding these components to our objects. Obviously, go into the course assets folder if you're using it, and we're going to want to make our sprite a square. So click on the player, and we're going to drag this square all the way over there. Right, now, it's rather big, which you might have a problem with if you're trying to make a mobile game. So we're going to actually change this property over here on all of our assets. So select the circle, hold down shift, the square and the triangle, and we're going to make the pixels per unit 1000. Once that's finished, we should have a much smaller sprite. Now I could keep scaling that down until I need, but instead select this rect tool and then click here, hold down shift and move it like this so that I can scale my sprite as I need to. Right, now that's a much better sprite, I'd say. Let's maybe make him a little bit bigger. That's much better. By the way, it should be noted that I am navigating around the Unity editor using my scroll wheel to zoom in and out and holding down right click to move around the scene. That's primarily how I navigate the Unity editor. There are different ways, but that one works for me. Then we can see the scale is set, these very big float values, and the Z scale is set, which we don't really need. So let's make that 0, and let's make these 0.32. It doesn't alter it that much, and it's just easier for the computer to store those values. So right over here, we have our sprite. He's just a square. If we click this game window over here, we can see how this will look once we play the game. And in fact, if we click this play button at the top, it will test our game and basically run everything. And we can see, obviously it's just a sprite, so it's not going to move, but this is how our character will look in the game. What's important to note is that if I make any changes during this game window, they don't save. So if, for example, I made him very long and then clicked over here, that change is not going to save. If I did it in the scene view, however, it would transfer over. That's just how Unity works. So you can make slight changes to your game while you're playing it, and you can test how they work, and then obviously it won't save. So keep that in mind. Now our character is pretty much done for the most part. We've done pretty much everything we can. We can't do much else to it at this time because we haven't learned any other concepts, but for now, the only thing we're going to do is change his color. So let's make him a nice yellow character. As we can see, that stands out a little better in our scene. We've got our yellow character against a blue background. Don't worry, we'll improve all of this later. But if you followed on, you should have created your first character with a player, sprite render component, added the square sprite or your own sprite, but I recommend using the official course assets folder, and change the color to whatever you like. You can even make him green or blue. I'm gonna stick with yellow for now because I like how that looks. And there we are. If you've done that, you've taken the first step to making your mobile game. The next thing we're going to do is create an environment for this player so he's not just standing in the middle of the abyss. But good job everybody, and I'll see you in the next video. Hey there, and welcome back to Unity. In our last episode, we created this player object and assigned a position and a scale as well as a sprite and a color to this object. What we're going to do in this episode, however, is we're going to create an environment to make our scene look a little bit more alive. Before we do that, we must first make sure that our Unity version is actually building for the correct platform we want, in this case, mobile. We're going to go to the top left and select File, Build Settings, and then choose a platform over here. I can select Windows, Dedicated Server, or Android, as those are the three platform modules I installed for this version of Unity. If I wanted to build for something else, I could simply select it and click Platform Module Installation, or for a simpler one, such as iOS, I could select Install with Unity Hub. PlayStation seems to have some weird documentation needed, but obviously we're not going to worry about that. I am, however, going to be building my game for Android, as I found it to be a lot easier to test. I recommend you do the exact same thing, even if you have an iOS phone like I do. I'm going to click Switch Platform, and after a short loading time, it should make sure that my project can run Unity for Android. We're going to then close this and go into our game view so we can select the right resolution we want. I've currently set mine to 2160 1080 landscape. But you can pretty much select whichever one of these you want. You can do 1920 by 1080 or even portrait, but I don't recommend you do so for this course because we're going to be building our game landscape. Now we've got the right aspect ratio, we're going to make our environment. But we don't want every single environment object we make to be here in a list because that's going to get very confusing. Instead, we're going to order them a little bit. So we're going to do so using folders or parent objects. I'm going to right click and select Create Empty. We're going to call this Environment. And this is basically going to store every single environment object we want. We can right click on this again and click Create Empty, and we can see that because we right clicked on the object, it's going to create a child object underneath it. We can call this Floor, and then we can see if we move the environment, the floor moves with it because it's parented. We're going to set the environment to 0, and we're going to go ahead and drag the floor down. Now all we need to do is add a sprite renderer, open up course assets, drag the square, and voila, we have a very square floor. We don't want a square floor, we want a more floor. So we're going to achieve this by dragging the y-axis down and the x-axis across to make sure that our floor is stretched horizontally across our entire scene. If we go to the game view, we can see that it is in fact covering the entire bottom half of our screen. Then the next thing we want to do is add a background or a sky, if you will. So we're going to go Environment, right click and Create Empty, and we're going to call this Background. Once again, add a sprite renderer, drag the square in and scale it up. The problem with this, however, is that this is going to go in front of every other object we have in our scene. To prevent this, what we're going to do is we're going to change this order in layer attribute that is attached to the sprite renderer. If we set this to something like -10, we can see that both our player and our floor jump ahead of the object. Obviously the floor is white, as is this, you can't really see that, but trust me, they have. If I move this and make it gray, we can see the floor is in fact in front. So I'm going to make the background maybe darkish blue, and there we go. The last thing is to make our floor another color, so I'll make the floor green. Right, we can see there is our very questionable looking mobile game color scheme, and we have made a very basic environment, but we're not going to stop there. We want to add some more objects. Now, we can keep making objects like I've been doing this entire time, or we can simplify the process a little bit. We can actually take these assets and just drag them right into our scene, and it'll create an object with a sprite renderer for us automatically. The problem is this object isn't in the environment folder we created earlier, so I'm just going to have to drag that and place it there, and you can see it moves right exactly where it's meant to be. Then I'm just going to scale this down, maybe make it 0.7 by 0.7. Always make sure to keep the X and the Y scale the same if you don't want to stretch your things, and that's actually not big enough, so let me make it not small enough. Let me make it 0.4 and 0.4. Then I'm going to move it down, and we can see, voila, we have a spike. Let's make this spike red. Now, this is a very small spike, and I don't want one small spike, I want 3. So what I'm going to do is I'm going to select this object, I'm going to click Control-C, and I'm going to hit Control-V, and it's going to make an exact copy of the object in the exact same position. So obviously we can't see it now, but if we drag it out, voila, there is our second spike, and we can actually do this twice and make 3 spikes, which looks a lot better. Now what we're going to do is we're going to go ahead and click our game view so we can see how it looks. Doesn't look bad. I think what I'm going to do is I'm going to go ahead and select the floor, select this rectangle tool, and then drag it down so it's covering the entire bottom half of the screen, which looks a little better in my opinion. The last thing we're going to do is add some coins. So we're going to use that quicker method we discovered, drag it right in. I'm just going to scale it down using the rectangle tool, and I'm going to put that over there. Now I think my coin color should be gold. That's orange. No, it'll work. Weird gold orange is going to be my color. I'm going to do the exact same thing I did with the triangles and just copy it across and make 3 coins. Then I'm going to select all 3 of these circles by holding down Shift and putting that inside the environment again. Now we can see our environment is all stored in this one object. So if we move the object, the entire environment moves with us. This could be useful if we want to make a weird game where the environment moves but not the player, but for our case, this is going to be a pretty static object. It's just used to store all of these different environment objects. Now, the last thing I think we should add is maybe a little bit of detail. So, first thing I want to do is make this slightly lighter because I don't exactly like how it looks now. I'm obviously going to want to just adjust these by holding down Shift and just moving them slightly up like so. I'm going to do the same thing with the coins so they look a little bit better. There we are, and I'm going to put the player on the floor so it actually looks like a game. Now our environment is looking a lot better now, but I want to move every single thing, including the player, a little bit to the right. But instead of doing that, I think I'll just move my camera to the left. Now the camera is going to be what's capturing every single object in the scene. We can see that if I move it, we can see the preview in the bottom right is changing. So if I want to make a camera follow script, I'd obviously move this and the camera would capture different parts of the screen. So I'm going to move that slightly to the left, maybe there, and everything's looking a little bit better in my opinion. Now our environment is basically done. Obviously we're going to need to add a little bit of logic to all of these components in a bit, but we're going to get to that later in the course. The coins and the things don't really do anything now. We click play, everything kind of just sits there statically. But we've taken the first steps to building our environment using Unity. Good job, and I'll see you in the next video. Hey there, and welcome back to Unity. Now in the last episode, as I'm sure you remember, we created this very questionable looking environment for our mobile game. What we're going to do in this episode, however, is we're going to actually delete some of the parts of this environment that we made because they're a little too complicated for where we are at this course, and we're going to assign logic to the ones that are left. Now this might sound like we're moving backwards, but we're not, because the point of the last episode wasn't to teach you how to make this exact environment, it was to teach you how to make new sprites, add them to your game, and order them using those parent objects we went over. So go ahead and delete all of the coins and the spikes in your scene. So you have just the floor, the background, and the player left. And then you're going to want to take your player and you're going to move them up so that they're suspended in the air. Now, this is a bit of a preemptive step, but trust me, I've taken multiple takes of this video now, and every single time I don't do this, it means you can't DC one of the things I'm demonstrating. So go ahead and take the background and you're going to want to make that a lot darker. Same with the floor and same with the player. And now this doesn't look great, yeah, I'll agree, but this is very important because I want to demonstrate something with a new component, and this component actually, the way you see it, has a green outline around the object, and we're not going to be able to see that unless we have darker colors, if there's more contrast. Because obviously we have light green, light blue, and light yellow, which is probably the 3 worst colors to have against light green in terms of contrast. So I'm going to go ahead and go to my player, now that I've made my thing a little darker, and I want to go and add a component, and I'm going to add what's called a box collider 2D. Now, I'm sure as you saw, there were 2 box colliders here that we could have selected from, the box collider and the box collider 2D. Pretty much whenever this is the case, when we're searching for components, if there's a 2D option, we're going to want to use it because we're making a 2D game. The 3D option won't work. Like later on, we're going to add an object called a rigid body. There's also a rigid body 2D, and we're going to use the rigid body 2D because it is built for 2D games, just like we're making. So I'm gonna go ahead and choose the Box Collider 2D and click that. And then it's going to add it to our object. And like here, you can see that green outline I was talking about. You might not be able to see it in this video, but you should be able to see it on your screen. There should be a green outline around your player now. And this outline is actually the collider that we just added. So here in the Box Collider 2D, we can see we've got a collider, a material, a trigger, used by effector, used by composite, offset, size, all of these properties. This basically changes how the collider works and looks on our object. So our collider over here is actually perfect for our player. It's exactly around the player. And the reason that this takes place is because the player is the exact same size as the sprite. Now this isn't always the case. Obviously under course assets, we can see this square is exactly filling the size of its container. But if we were using a circle, for example, and we added a box collider, we can see that it goes on the outside there. That green line over there is currently now on the outside of the thing because that's the size of the sprite. So because we're using a square, we shouldn't have that problem, but that's just something to note about later. If we want to add a box collider and we want to change the constraints of it, we'll go to this thing that says edit collider, and then we can change and scale the collider just as we see fit to make sure that it fits how we want it to. Now our box collider over here is basically going to tell Unity that when we are colliding with an object, if I drag this down and I go over the floor, that's going to trigger the collision event and Unity is going to react accordingly. Now, because this is a normal box collider, what should happen when we fall is actually going to stop because it's a normal box collider. We'll get into another type of box collider later, which is called a trigger, and we can actually change this to a trigger by just ticking that. And then it's not going to stop, but it's going to trigger the same event. So we'll use that obviously. If, for example, you're making something like a bullet, like a projectile that goes through an enemy, you'd want to make that a trigger because then it's not going to stop when it hits the enemy. It's going to go through, but the enemy's still going to trigger an event. You can say, okay, take that much damage. Obviously, that's a little higher grade now, but we'll get into that later. If we do run the game, however, we can see that we're just going to stay suspended in the air, not colliding with anything. So we're not going to see the effect of the collider. And if we actually move this down, we can see we go through everything. Now, this is for two main reasons. One, it's because the floor doesn't have a collider attached to it too, so we're not really colliding with anything. We're just kind of colliding with nothing because it's just a sprite, it's not a collider. But the second reason is actually that because we're moving using the scene tool, collisions won't take place. So even if this was built so that a collision could take place, we wouldn't see it now, which isn't great, but it's fine because we're going to add another component later that lets us see the collision. So don't worry about that right now. I was just trying to demonstrate how this is not going to collide because we don't have another collider. However, to fix that, we're going to go back to our scene, we're going to click floor, we're going to click add another box collider 2D. We can see again, it goes exactly on the outside right where we need it to because this is the same square sprite, which is very cool. Now we have two colliders, and if, for example, we're playing a game and this one were to collide here, it would stop. But because we don't have any movement in our game, we just have two static objects with colliders, it's not really going to do anything. Like I said earlier, if we move it here, this ignores laws of physics because I'm basically moving it using a scene thing, even if I'm in play mode. So to actually demonstrate these colliders, we're going to add another component and we're going to introduce physics. And this component is going to be called a rigid body 2D. And this rigid body 2D basically is an all built-in one add physics to this object component. And see if we hover over different aspects of the physics, it has the body type, the material, the auto mass, the normal mass, the linear drag, the gravity scale, pretty much anything relating to physics, or at least the first part of physics, Newton's laws, is in this rigid body 2D. We've got acceleration, we've got gravity, we've got everything, pretty much everything that we need in terms of physics is going to be covered by this rigid body. Now, this obviously can also help us if we wanted to make something bounce or make something collide and then do something else. We're not going to get into that right yet because we're not going to need for our game, first of all. We don't want bouncing sprites. And second of all, that's a bit more complex, which we might get into later when we have collisions. But for now, all we're going to use this rigid body to do is test to see if this character will fall and stop because we've added the two colliders. So if I go ahead and hit play, we can see that it does in fact do exactly what we wanted. We've now added physics to this object. We can actually move this and we can see that the physics is, obviously it's a little weird when I go up because this is not really how you should be testing stuff. Like I can move that up and put it back and then we can see, see what I mean? So I actually went through the player there because I'm moving it so fast. This is a weird way for Unity to see these collisions take place. Obviously this isn't how anyone will actually be playing the game. I'm moving it in the editor. But yeah, I thought this would be cool to demonstrate how the physics actually works. This rigid body that we've added to the player is basically all of the default settings here are pretty much all we'll need. We don't really need to change too many of these, but I'm going to change a few just to make it slightly nicer. The first thing I'm going to do is going to make collision detection continuous. And this isn't required. This basically makes it so that you can, I'm sure you saw when I was moving it up and down, at one point it went through the player. If I have like that, and if I have continuous collision detection, the chance of this happening is minimized because it's continually checking if it collided there. I think the only reason it went through there was because I was, again, moving it in the scene. But I think in an actual game, anytime it moves over, it would sense a collision. So that's just good practice. I generally set that on my rigid bodies, but it's not required. Angular drag, I'm also going to make 0, and I'm going to make the gravity scale 2. I always find that gravity scales of 1 are a little too floaty for a game. So 2 should be a sweet spot like that. You can see that's a little more gravity-like. So yeah, once we've done all of that, there's only one more thing we need to do to make sure that our game or our character has introduced physics correctly. And that's going to be freeze this rotation. Now, you might not know what this does. I'm going to demonstrate over here. If I move this so that he's going to land on that corner, on that vertex, you can see that the player is going to fall, and then just like real life, bounce off and like roll and fall off. And this is very realistic and it's very cool. But for our game, if we leave this ticked, it just causes problems later on. If you think about if we're moving and we hit something that we don't want the player to be rotating mid, you take Geometry Dash, for example, you can see that while the cube spins when it jumps, the square rather, it never actually changed the rotation when it bounces off things or falls off things. And that's pretty good practice for mobile games, because imagine we're trying to play our game and then we fall like that, and we have to keep playing our game as a sort of sideways square. It's not ideal. So we're going to go ahead and click Freeze Rotation Z. And then if we go back to that example, move that over there, and we fall, we can see that we no longer fall. We stay on the edge, and we can actually stay on the edge right up until nothing is colliding anymore, in which case we fall through. So that's the beauty of these colliders, and that's what freezing our Z rotation does. After we've done this, we've pretty much done everything that we need to in this lesson to cover the basics of an introduction to physics. We could also add a rigid body to this floor, but as I'm sure you've guessed, then the floor would just fall just like the player has, and that wouldn't be ideal. And there's really no point to adding a gravity scale of 0 to this floor object because it's just a little tedious. We don't need it for our game. So for now, we've pretty much done everything that we can, and we've introduced physics into our game. We can see now we have a falling cube, which is very cool. It's going to allow us to start the next lesson, which is actually going to be adding our very first C# script, and we're going to make it so that our player can move around. Hey there, and welcome back to Unity. Now in the last episode, as I'm sure you remember, we added a rigid body and a box collider to our player object to make them affected by gravity and collide with the floor, which we also added a box collider to. Now this is cool and all, but there comes a certain point in our mobile game development journey where we need to actually start writing our own code if we want the objects to do pretty much what we want. In this case, I want to create a movement script for my player to start making this game, a game, because currently all it really is a square that falls to the ground. Not super exciting. Now to do this, I'm going to need to start writing my own code, and this can be a bit of an intimidating thing to do when you're just starting out. But luckily, I have created a sort of cheat sheet code file inside the course assets folder, which you hopefully installed earlier. If you didn't, you don't need it, but I do recommend you install it because it can be quite useful. If we go ahead and open that up, I have got over here a list of all the very basics of coding, which with examples. And while most of these things don't really do anything yet, this can be helpful, especially later on in the course when we learn about them, for you to come back and check if maybe something's not working, that you've got the syntax right. So right at the top, we have variables, and I'm sure you remember from our introductory video, variables are basically just storage spaces for different types of data. This X variable stores an integer or a number. This Y variable stores string or text. This Boolean variable Z stores a Boolean or true or false. And this rigid body RB stores a rigid body component, which is the exact component we added to our player earlier. Making variables like this will allow us to actually reference them in our code. So we can go ahead and assign that specific rigid body to this variable we made called RB, and then alter the RB variable, which will in turn alter this rigid body. For instance, if I wanted to change the gravity scale, I could write code that said rb.changeGravityScale, and then RB, whatever it's linked to, which would be a rigid body, which in this case would be this particular rigid body attached to the player, its gravity scale would be changed. Now underneath this we have arrays, and I've never gone over arrays before, and we're going to get into it later in the course. We won't need them now, but it seems like a decent thing to just at least go over right at the start. Now what arrays are basically like variables but in a list. So you can see over here it looks exactly like public int x, except it's public integer and then it has two square brackets afterwards. And what these square brackets basically mean is that I'm not going to store one variable in here, I'm going to store many variables. And so this public int x array is basically going to store a list of variables called x array, different ones. You can say, okay, the first variable in x array, and you can assign a value there. Then you can assign a second value and a third value. And this is actually really useful. If, for example, if you think about we want to maybe store all the scores of a leaderboard, we don't want to make a different variable for every single score. Well, it'd be better if we make public integer array, call it scores, and then assign every single player's score to a position in this array. Done the same here with a string, which you can maybe use to store dialogue or text or something like that. If this doesn't really make a whole lot of sense to you right now, I don't blame you, because it will make a lot more sense when we do it, but don't worry. I just wanted to cover the very basics of what arrays are. Underneath that, we have procedures, which we have gone over in our previous video. Basically, procedures are just areas of our code which we call at certain times to accomplish certain tasks. So this void start, this procedure, is actually auto-generated by Unity, and this is the procedure which Unity calls whenever this code runs for the first time. This update procedure is very similar, except this procedure Unity calls every single frame. We'll get into those a little later when we're writing our movement script, but just know that these procedures are just like we talked about, except Unity's calling them. We're not calling these. Underneath this, we have another example of a procedure. This procedure is called open chest. Obviously, it doesn't do that, but I just wanted to demonstrate that you could actually write your own procedures. Underneath this, we have our new concept called local variables. And local variables, we can basically write in the syntax. Syntax is the text format we need to write stuff in code to make sure it works. We can write that with the syntax int x equals 3. And what this is basically going to do is this is going to make a variable called x, set it to 3, but this variable is only going to be referenced inside this method. Once this method runs out, the variable gets effectively destroyed. If I call this something like local var, and then I go ahead and try and reference local var in here, we can see that there's nothing called. If I type it in, it says the name local var does not exist in the current context. If I move it inside this procedure, however, we can see that it knows exactly what to do, and it doesn't say it doesn't exist because it's right there. We've assigned it already. So underneath this, we have our if statements, and these are conditions. And this is practically one of the most fundamental aspects of coding, conditions. If statements, if else statements, if else if, etc. I'll get into all of those now. Basically, all these statements do is they check logic. So, for example, if we're making our jumping script and we want to know if a player's landed, we'll check that using an if statement. Well, not exactly in our case because it's not great for performance, but if you could theoretically check every single frame if player grounded, and if he is, then say can jump, for example. Over here, we're saying if x is greater than 5 or x is equal to 3. A good example of if statements is if we were trying to calculate whether the player has scored a high score. So if he did, you could say if score greater than high score, or if score equal to new high score, or if high score is less than our current score, then run code which basically says, okay, this is a new high score. And this else statement will only run if this statement doesn't. So what this actual code is saying is if my variable x is assigned to the value 3, run this code. If it's assigned to anything else, run that code. And we can actually expand these statements a little bit by going, if x is 3, do that. Otherwise, if x is equal to 5 or 4, do that. Or if x is equal to 5, sorry, I put one equal sign instead of 2. X is equal to 5, do that, else do that. And this code is a little more complicated. It's going to say, okay, if it's 3, do this. If it's 4, do that. If it's 5, do that. Anything else, do this. And this kind of code isn't great because you can see that the computer has to run through that, then that, then that, then that. But for our first mobile game, if we code some things like that to make it a little bit easier to understand, it's completely fine. It's part of the process. Underneath that is the final concept which I want to teach called loops. And loops are effectively ways of running the same code over and over again. This for loop, which you might have heard before, basically runs a certain amount of time. So what this for loop does is it says for x is equal to 0 at the start, while x is greater than 3, increase x at the end of the loop. And what that's basically saying is we have for over here, we're saying, okay, I want to use the x variable, and at the start of this loop, I want to make sure it's 0. Then after that, I have a condition which must be met for the loop to keep running. So in this case, as long as x is greater than 3, keep the loop running. And on the last thing, I have code which runs at the end of every single loop cycle. So basically saying, at the end of every loop cycle, x++, which is basically code for x increased by 1. You can make that x plus 3, x plus 5. In this case, I have x++, which means increase x by 1 at the end of every loop. So what this loop is saying is, for set x to 0, while x is greater than 3, run the loop, and increase x every time. So this loop's actually not going to work. We're going to have to change that to less than 3. That'll make a whole lot more sense. This is basically saying, okay, while set x to 0 at the beginning, while x is less than 3, keep doing with the loop and increase x every time. So if we had to write something in here, that loop would execute twice, or 3 times rather, because you can see runs the first time at 0, then it increases, it's 1, it's still less than 3, so it goes again. 2, still less than 3, it goes again. 3, not less than 3, so then the loop ends. Underneath that, we have while loops, and while loops basically do the same thing as for loops, except the condition for a while loop just needs to be true, and the while loop will continually run forever. So if we're never changing x, this loop's going to run for infinity, because if we set x to be 2, it's going to go, okay, x less than 3, okay, x less than 3, nothing's going to change. The for loop will run a set number of times, but a while loop can run for infinity, which makes them a little bit more troublesome sometimes when we make errors, because if we have an error that causes this loop to run for infinity, it almost always causes a crash. And that is not great for our computer or our code. It's not bad, it doesn't break anything, but just in terms of our peace of mind, sometimes it causes the whole Unity to have to close, and then we might have not saved something. So I would recommend not using while loops until you have a complete grasp of them. I don't foresee us needing while loops throughout this entire course, and generally speaking, while loops are a bit of a niche thing that you don't always need in coding, but you do sometimes need it. Just make sure when you use a while loop, you use it right and so that it does have a terminating condition, because otherwise you can cause a crash. Back into Unity now, we're going to try our hand at making our very first script from scratch. I'm going to do that in the assets folder. So I'm going to go to assets, I'm going to right click, we're going to go create, we're going to make a folder and call it scripts. This isn't required, but it basically just means that we can put all of our code in here, so it's all nice and organized. You don't need to do that, that's just how I like to organize my assets. I'm going to right click again, and we're going to go create C# script, and I'm going to call this one movement. Now, if I double click the movement script, it's going to open it up in Visual Studio, just like I wanted to. And we can see over here in our script, we have 3 lines at the top, which are all using system collections and Unity Engine, then a class called movement, a start procedure, and an update procedure. Now, I don't know if I covered this in the previous script, but basically what these green letters are comments. And that's basically the way of saying, okay, I don't want this code to run, but I want to have it as text. So if I wanted to write something underneath, like this program is cool. Obviously, if I write that without comments, Unity is going to be very confused. It's going to be like, what is he trying to say here? There's no token, syntax error, the name cool does not exist, the name this could not be found. It's basically saying, what is this? What's program? Why are you using the is code word here? What's cool? It's been very confused. So what these 2 forward slashes do is tell Unity, I don't want this to run, I'm just writing plain text so I can communicate something to someone who reads my code. For example, when you make this file, Unity auto-generates 2 comments over here for you. They tell you how often the start procedure is called and how often the update procedure is called. They say start is called before the first frame update, update is called once per frame. And that's the Unity developers telling you what these 2 procedures do so that you know. You can also hover over them and it'll tell you the exact same thing. So what basically that's saying is that Unity makes these procedures and they call them on their own. We don't have to call these procedures. And we can use these procedures that Unity calls to build the rest of our code. So we can delete those 2 comments and we can start making our very first movement script using these 2 procedures. The first thing I'm going to do is make a couple of variables. The first variable I want is a public rigid body 2D RB, and that's going to be to create a reference to the rigid body stored on the player so I can make them move. I'm going to create another variable, a public integer, and I'm going to call it speed. That's going to be the speed that the player moves at. I'm going to create another variable, I'll call it jump force. That's going to be the speed at which the player jumps off the ground. I'm going to create another variable, and I'm going to call it grounded. And that's basically going to tell us, is the player grounded or not? Obviously, we can only jump when we're grounded. Now, as a warning, I'm going to be writing all of this code using keyboard commands. I'm going to say if space is pressed or if this is pressed. You might be thinking, why? We're making a mobile game, and that's true. But if I want to test my game in the Unity editor, I can actually write keyboard commands, even though I'm building for Android, and Unity will be like, okay, just use the spacebar. And then when I build the game for Android, obviously those commands are never going to run. So if I write under here update, if I say, if the person presses the spacebar, jump. Then when I build my game for Android, there's no way you're going to be able to jump because it's for the spacebar. But while I'm testing it in Unity, it's what I'm going to use to make sure everything works. That's actually how we're going to be doing this course. We're going to build all of this course, test it for a computer, and then right at the end, I'll show you how to change all of your input commands so that they work for mobile. It's actually really easy because we're not going to have that many controls. We're just going to have a jump, and that jump we're going to trigger by tapping. But for now, we're going to do it via the spacebar to make things a lot easier to test. So I'm going to type if input.getKeyDown, then I'm going to open bracket and say keycode.space. Then underneath this, I'm going to open curly brackets, which we do whenever we use an if statement or procedure. We type the open curly bracket and then we press enter and it formats them nicely for us. I'm going to, over here, let me delete those. I'm going to say comment in jump. And obviously this comment, like we went over, isn't going to run, it's just text. But basically what this is going to do is I can use this to store code I haven't written yet so I know what I must put there. So now every single frame, if I get the space key down, I'm going to want to jump. Now I don't want to jump every single time I press the space key. I want to jump only when I'm grounded. So inside that if statement, I'm going to put another if statement down. I'm going to go if grounded. I'm going to open those brackets again. Now this is what's known as a nested if statement. It's an if statement inside an if statement. I could actually write this as one if statement, but for simplicity's sake, it's a lot easier to read in my opinion if you do it like this, and we can learn about those compound if statements later on. We're not going to cover that now. Now, if grounded, we're going to want to jump then. We're not going to want to jump if we're not grounded. So now we actually need to write a little bit of code to make sure that we can actually jump. So I'm going to go over here and I'm going to make my own procedure. I'll write public void, and I'm going to call it jump. Put parentheses, and then open curly bracket and press enter. And inside my jump, I'm going to write code to make me jump. So I have this reference to the rigid body, and the rigid body is what we're going to be using to jump. I'm going to type RB, and that basically retrieves the rigid body. Now I can do dot, and I can change velocity. And that basically means I'm going to be altering the velocity of the rigid body. That's the linear velocity, so it's up and down and left and right. And I can make this velocity whatever I want. I can go equals, and then because I'm putting in two values, an x value for x velocity and a y value for y velocity, I'll type new vector2, and then open parentheses and close parentheses, and then a semicolon. We always put a semicolon at the end of our code. And what this is basically going to do, it's going to say, okay, set the RB velocity to whatever I want. If I go 5 and 5, the RB velocity when I jump is going to go like this, whoop. And if I set it to -5 and 5, it's going to go like that, whoop. Set it to -5 and -5, like this, it will go whoop. And if I set it to, for example, 0 and 5, it'll go whoop. You might be thinking, oh, that's what we want because we want it to jump. But if this is the case, our game would basically go like this. You jump, and then you carry on moving, then you jump. We don't want that. We want to jump with the same momentum you've been carrying the entire time. So in other words, we want to keep the velocity of whatever the rigid body is in its x directions. If you're moving back or forward or standing still, we want to keep that. And we only want to change the y. So I'm going to make this y value jump force. And that's the variable we made over here. So currently this integer is set to 0 because we haven't assigned a value to it. But we can go into the Unity editor and we can change jump force to whatever we want, and that's the speed with which you jump. And then instead of putting 0 here, I'm going to type rb.velocity.x, which is basically saying, okay, make the velocity the x velocity, so don't change the x velocity, but make the y velocity whatever value is stored in jump force, which is going to be a number which we're going to assign whenever we want. And that's pretty much all our jump code needs to be. We're going to jump up, and fall back down. And this should actually work if we go into Unity, if we simply remove the comment from this and put parentheses after. And then we're actually calling this method, because we've typed jump parentheses, we're calling this method. If I had another method called jump up, I could type jump up parentheses, and that would call that jump up procedure. But because I don't, it doesn't find anything. Because I have this jump procedure though, I'm calling the jump procedure as long as I press the spacebar and I'm grounded. Now, I'm going to jump up and land back down. Obviously, we haven't finished coding that yet, but if we go into Unity, that should actually work just how I want it to. The only thing I am going to need to do, however, first of all, is I'm going to need to assign a few of these values. So the first thing I want to do, if you haven't already, drag obviously your movement script onto the player like so. Then, once you've done that, take your rigid body and drag it onto this RB variable so we have a link to them. Then you can set the speed to whatever you want. I'm going to set to 5. Obviously, we haven't coded that yet, so it's not going to do anything. And I'm going to make my jump force 5 as well. Then I'm going to tick this grounded variable, because we can see in our code, I can only jump when I'm grounded. And because I haven't actually coded the grounded logic yet, I'm never going to be grounded. It's automatically going to set to false, and I'm not going to jump. But if I set ground to true, it should work. So now if I'm playing and I press jump, you can see I jump up, which is really cool. We've now coded a very pathetic little jump. And the reason we use variables is because I'm sure we can all agree that jump is nowhere near high enough. So I'm going to change this jump force and make it 10. See, that's a little better. I think that's almost good enough. I'm going to make my jump force something like 12. Then whoop, we have a nice big jump for our mobile game. Now, as we covered in the first episode, if we make changes during play mode and we click away, they don't save. But I can just remember what value I had, put that back in, and then I won't have to actually go into my code and change this variable 5 or 12 or 7. I can just change the variable, and then I can change whatever's stored in there, which is really cool. Now we have our jump working, we want to make sure that we can only jump every time that we hit the ground. So we're going to go ahead and make 2 new procedures, and both of them are automatically generated by Unity. The first is going to be on collision enter 2D. We're going to say grounded equals true. The second is going to be void on collision exit 2D, and we're going to set grounded to false. And basically what this is going to do is this is going to say every time we collide with something, make grounded true. And every time we uncollide with something, or no longer are in contact with it, set ground to false. And if this works correctly, we should set ground to false. And at the beginning, we can go over here and we can see grounded's false. And as soon as I land, grounded's actually set to true. Then if I jump again, grounded's false, and then true again. And that's basically all the script we need to make our jump code. We can press space as much times as we want. We can only jump every time we land, which is really cool. Now, this will work, but the problem is this is a little bit of a sticky situation, because if I leave the code exactly like it is, and then I collide with a coin, I'm technically colliding with something. So Unity's going to be like, oh, he's colliding, he can jump again. But I only want to be grounded as long as I'm touching this floor material. So I need to make a way to differentiate between this floor and all other colliders. And I'm going to do that with tags. I'm going to go over here to the floor, click on floor. I'm going to click tag, then add a tag, and I'm going to add a ground tag. And then we can go over here back to the floor and we can assign that ground tag over here. You can add tags simply like I did, add tag and then type in the name. And then we have a ground tag. So now we have a way to differentiate between whether what we're hitting is a ground or anything else. So going back to this, our code, I'm going to go over here and I'm going to type if collision.collider.compare tag, open brackets, quotation marks, ground. And then I'm going to open curly brackets. I'm going to say grounded is true. Obviously, I could type equals true at the end here, but that's actually going to do that automatically for me because I have, equals true here. But that's doing that automatically for me because I'm not putting anything in, it automatically sets to true. In the same way, I can actually type this if grounded, that's meaning if grounded equals true, but instead of writing if grounded equals true, I'm just writing if grounded. It's a simpler way of doing it. So over here, I'm going to say I'm grounded as long as I'm colliding with the ground. I'm going to copy this exact code and put it under my exit thing, except changing this back to false. Now what this is going to do is basically not change anything, but if we were to have another collider that we collide with, I'm not going to be grounded unless it's the floor. This might seem like a bit of a weird thing to do now because our code was working fine, but trust me, it will save us a headache in the long run. The last thing we need to do is make sure that we're continually moving to the right, because we need to move to our game, just like in Geometry Dash, so that we can interact with obstacles and jump over things. And we're going to do that using the speed variable. Now this update is called every frame, like we've covered before, but we don't want this update to be called every single frame. We want it to be called every fixed interval, so that it doesn't change if we're running the game faster or slower. And that you can use void fixed update for. Now fixed update is exactly like update, except instead of every frame, it's every interval. So I think it's 0.01 seconds or 0.15. You can set it in your code. But yeah, that's basically what that's going to do. And I'm going to go ahead and type rb.velocity, like I did before, equals new vector2. Except this time, I don't want to change the y velocity, I only want to change the x velocity. So we can actually copy this exact code over here and kind of swap them around. So instead of saying rb.velocity.x over here, I'm going to type rb.velocity.y in the y thing. And then for the x, I'm going to set it to speed. And what this is going to do is every single fixed frame, so every interval, I want to make sure my velocity is equal to the speed I want to travel at and keep the velocity of y. And every time I jump, I want to keep this x velocity and jump. If we go back into our code and we set our speed to something slow like 2, we run our game, we can actually see this in action. You can see over here, we're sluggishly moving along. And if we jump, keeping the momentum. And that is basically going to be our movement script for the start of our mobile game. This is the first step we've taken to making our mobile game, and it's a really exciting one. So if you followed along, good job. If a few things have sounded a little overwhelming, I completely understand, and I have actually linked my original code in the resources section of this video, so that if yours didn't work, you can fix it up and make sure everything's perfect so you can carry on with the course, because I don't want you to be stuck on this video. I do hope, however, that this video has explained these concepts quite well, and if you've copied my code exactly as I like this, you should have an exactly working program. I'll slowly scroll over it so you can pause the video and see if there's anything you have different, but everything should work fine. Just check you haven't misspelled anything like collision or collider, and there's a few concepts in here like compare tag and velocity, which we covered quite quickly, but that's just because they're not super important at the moment. They're just used to do the movement of our character. So we're obviously going to repeat them, it's going to become a lot more familiar. But if you've gotten to a point where your character can move and jump, great job. You've taken a massive stride in your mobile game development journey. I'll see you in the next video. Hey there, and welcome back to Unity. In our last rather long episode, we created our very first C# script and integrated it into the Unity editor, which allowed our player to move along the scene and jump. This is great. It's a really big step towards making our mobile game a reality. And we can actually see it in action here, just like we did last episode. We can move along and jump. And obviously we can only jump when we're on the ground, which is really cool. The problem with this is that once we reach the end, we have no idea what happens to the player because we're just seeing this. I mean, us as the developers know that the player is currently plummeting to his demise in the editor into the abyss, but the players will have no idea that's happening. So to minimize this issue, what we're going to do is we're going to create a camera follow script. And we're going to make sure that the camera is always following the player to make sure that we always know where we are as the players. Now, we're currently a bit lost in the editor, so I'm going to teach you another quick trick with Unity. You can double click on the main camera and it'll take you right back to where you want to be. You can do the same thing with the player or the environment. Basically zooms in, right? So if we've lost somewhere in the editor, we're like, oh, where am I? Double click the main camera and you are back. Now, let's go into script and make our camera follow script. Right click, create C# script, and we're going to call this camera follow. Make sure you don't name your script camera because that's a reserved word, and I did that a while back and I ran into so many issues and I don't know what was causing it, but yeah, thankfully you don't have to make the same mistake I did back in the day. So yeah, now go to the main camera and make sure your camera follow script is assigned to your camera. Also, as a general note, when naming scripts, make sure to not include any spaces, as this will make Unity unable to read the script because this name over here, the class, has to correlate with the name of the file. And obviously this class name cannot have a space because then the code won't know what the class is and where the mono behavior starts, and it's a mess. So make sure it's one word. Now, open up your camera follow script and we're going to start by making our variable just like we did last time. Except this time, instead of referring to a rigid body or a string, we're going to refer to a game object. And this is basically just a fancy way of saying we're going to make a variable that stores an object. As we covered right at the beginning of the course, objects are anything in our game which we can assign logic to. So the player is an object, the camera is an object, this environment's even an object, the floor and the background are both objects, and yeah, pretty much anything that can have logic assigned to it is an object. So we're going to create a public game object player, and this is actually going to allow us to choose one of these objects and assign it to our script. So if we go to our main camera, we can actually make sure that your camera follow script is assigned. Mine is, but if yours isn't, remove it and just drag it in. And we can drag the player into this player thing and make a link to our object. So the player variable is now linked to the player object, which is really cool because this allows us to access all sorts of information about this object, including its current position, which is really, really cool because as we play our game, I'm sure you can see the position of the player, it's constantly moving, and that's why our camera is not able to track it. So if we can move our camera in according to the position of the player, it's going to be really, really great for our players. To do so, we're going to go ahead and delete the start method. We're not going to need it for this script. And we're going to go into the update, which, as we covered last time, is the procedure that Unity calls every single frame. Obviously, since we're building a camera follow script, we want to make sure that the camera and the player's positions are synced every single frame. Now to do this, we're going to go here and we're going to type transform with a lowercase t. And this is basically Unity's way of saying whatever object is currently got this script attached to it, access that transform. So the transform attached to this game object, we can see if we hover over. And this game object in this case is the camera because that's what the script's attached to. Then we'll go dot. We can see all the different parts of a transform. We can do transform.position, transform.local scale, transform.rotation, anything we can think of. But we're going to need transform.position right now. So we'll go transform.position. We're going to go equals. Then here's where the cool part comes. Because we've made a link to our player, we can type player.transform.position. And then if we hit enter like that, this is basically all the code we need to make sure that our transform, our position, is always set to the position of the player. If we run our game, this actually looks like this. Right, now you might be a little confused. I'm just seeing a blue screen. And yes, you are seeing a blue screen. And the reason for this is because the Z component of the camera always has to be less than the rest of the scene. Otherwise, it's on the exact same plane and it's not capturing anything. Now, I know this might be a bit confusing because it's a 2D game after all. Why does the Z component of anything matter? And generally it doesn't, but just make sure that as a general rule, all of your Z components of everything else is always set to 0 and the camera is always less than 0. If it's -1, that's fine. If it's -100, that's fine. But -10 is a good sweet spot. Now, we don't exactly want the camera to always be the exact same position as the player for obvious reasons. So instead, what we're going to do is we're going to only assign specifically the X position of the camera to the player. And you'd think you just go transform.position.x equals player.transform.position.x. But for some reason, Unity doesn't make it that simple, which is a little annoying, but it's fine because it's actually very simple to do it. All we need to do is use those vector 3s or vector 2s that we talked about last episode. So go transform.position equals new. Then we'll type in vector 2. We can see it's not autofilling because I've got player.transform.position in the way. So I'm going to go ahead and delete that and just try to type that again. See there, vector 2. Oh, vector 3, sorry. Then we'll open square brackets and we're going to type in player.transform.position.x. And this basically means every single frame, make sure that my X position is the same as the player's. Now, that's actually the only position that we want to alter. We don't want to change the Y, we don't want to change the Z. So instead of changing player.transform position of the Y and the Z, we're going to just make it set to the transform.position.Y and the transform.position.Z. And what this is basically going to do is this is going to make it so that our position is always set to the player's position in the X, our position in the Y, and our position in the Z. Now, there is actually a simpler way to do this because we're only using the transform quality of our player game object, we can actually use a transform, which basically says, okay, I want the position and the rotation and the scale of that object. I don't want anything else, which is great because that's all we need. We can then take out all of these transform keywords. Oh, actually, it's just that one because these are all referring to us. And now it's just player.position.x. This might seem a little pointless, but storing a transform is obviously a little less than storing a whole game object. So it's going to be good coding practice. We we can see over here it says type mismatch, and that's because it was storing a game object and now it's storing a transform and it doesn't know what to do with itself. So just re-drag that player in and it'll sort itself right out. Now, if we go ahead and click play, we can see that our camera is in fact going to be following our player just as we want it to. The player is always in the center of the screen, and when we jump and we fall back into the abyss, we can see exactly why it happens. Now, this might look cool and it might work fine, but we actually don't want the player to always be in the center of the screen. We want there to be a slight offset. I prefer to play my games where the player is like there, and I'm sure in most games you'll find that's the case. So we're going to go ahead and make a offset variable. We'll call it a public float, and this is the first time we're using floats. They might sound complicated. They're just decimals. That's all they are. They're 0.5 or 0.2, 0.45. Anything that's not an integer is a float. So any real number pretty much is a float. And we're going to go ahead and type offset. And this is basically going to allow us to add this offset value to the players.transform.position.x, which basically will offset the transform. So if you think about it, if the player is at position 0, we run this, we're going to go to position 0 plus 5. So then the player is going to be over there. Let's say the player is there, the semicolon will be over here. Or if we set to -5, we'll be there. And we can alter this in play mode just like we've been doing with everything else this entire time. So if we start our game, we can see, oh, we're in front of the player, but I want the player to be about there. And we can actually save this value, 5.78, go out of play mode, type it right in, and then when we start our game for the second time, we can see the player is exactly where they should be, right over there. I'm actually going to make it 6 because I think the player is still too far to the right. And yeah, that should do the trick. It might be a little bit too much to the left now, but we'll come across that bridge when we come across it. You might actually prefer to have your player on the other side, like there, which is fine. If you do, we can alter that value as we go along our game development journey. That's the great thing about variables. But for now, we've created a very basic script that allows the camera to follow the player. Good job, and I'll see you in the next video. Hey there, and welcome back to Unity. Now, over the last few episodes, we've created our very first C# script, allowing the player to move along the scene, and we've even added a camera follow script so that we always keep track of where the player is. As a result, our game currently looks like this. It is in a semi-functional state, and we can jump, and only when we're on the ground we can jump, which is really cool, right up till we reach the end, and then we fall off. Semi-functional might be a little bit of a stretch, but regardless, in this episode, we're going to start by creating player states. And this is going to be the first step we're taking to creating a game loop. Now, if you don't know what a game loop is, it's basically the fact you can play, die, play again, die, play, win, etc. You can continually play or loop. And states are going to allow us to determine what state the player is in. If he's dead, if he's alive, if he's waiting to see if he can respawn after an ad, if he's jumping or falling. Obviously, a lot of those we're not going to be using. We're not going to be coding jumping and falling states in, but if we weren't using a game engine, it might be something we'd have to do. Luckily, because Unity has this great rigid body component which takes care of all the gravity for us, the only states we're going to focus on in this episode are going to be whether the player is playing or allowed to move, or dead, not allowed to move. So, start by going into the scripts folder, right click, go create C# script, and I'm going to call mine state manager. Then, once that's been created, go over to the player and drag your state manager script onto it, like so. Now, we're going to open up our state manager script, and we're going to start, just like we usually do, by creating a variable. And this variable is going to be called state, and it's going to be a string variable. Public, so we can see it in the Unity editor, string state. Now, this state variable is going to allow us to check what state the player is currently in. And we're going to do that, we're going to reference this state in other scripts, like our movement script. So obviously right now, our movement script is what's actually telling the player to move every single frame. This line over here tells the player to move every frame. But if the player is dead, we don't want him to move every frame. We want him to stop moving. And we're going to do that by referencing this script. Now, if you're not sure how to do this, I don't blame you, because this took me quite a while to learn. But it's actually quite straightforward. If you've guessed it already, all we need to do is create a variable that links this script, just like we've created variables that link rigid bodies, integers, even other transforms and game objects. We're going to do the same here. So we're going to type public, then we're going to type the name of our script, state manager, and we're going to call this state manage. Then once we've done that, we're going to go back into the Unity editor. we're going to go and select our player object, and we're going to drag our state manager script into our state manager variable, which will then allow us to access this script from this script, which is really, really useful. Because then what we can do, we can go over here to fixed update, and we can type if, because we want to only do it under a certain condition. And we're going to call state manage dot state, and we can actually access variables in this state manage script simply by typing dot and then the name of the variable. Then we're going to type 2 equal signs, and then we're going to say playing with a capital P. Underneath that, we are going to put our code over here, meaning that every single frame, only if we are in the playing state, we're going to set the RB.velocity to that. Otherwise, we're not. This is going to be really cool, because if we go into Unity and we hit play, we can see that we actually don't move. And if I were to enter playing into this state, I'll start moving. But the minute I change something, I'll stop, which is actually really, really cool, because that's going to allow us, as I'm sure you can figure out, to make different states for our player. So the way I'm going to do that is I'm going to go over to the state manager script. And now the last thing I need to do is make sure that this state is assigned based on what I want the state to be. So when I start, I'm obviously going to want the state to be equal to playing. So we start moving. But when I collide with something, I'm going to want to die. When I collide with an obstacle, I'm going to want to trigger the death state. And this death state is going to be exactly what it sounds like. It's going to make this state into dead. And then obviously we will no longer move. And what's cool about this is actually later on when we add death effects and all sorts of things like that, we can use the state machine to simplify that process. So I'm going to delete my update because I'm not going to need it here. And I'm going to create a new onTrigger event. Now, if you remember last episode or 2 episodes ago, we had our onCollision events. And this is basically saying when I collide, do this. And this code, obviously, as we went over, when I collide with the ground, I want to set ground to true. We're going to create something very similar over here. We're going to go void onTrigger enter 2D. And onTrigger enter 2D is exactly the same as onCollider enter 2D. It's just the collider is a trigger. So because our player is going to be using a normal collider, you might be, why are we using a trigger? But the reason is actually because the obstacles we're going to add in a second, we're going to use triggers for. And that onTrigger event activates when a collider hits a trigger, but it doesn't activate when a collider hits a collider. So we're going to go over here and on our trigger event. Now this is going to be quite a long line of code, and it's going to be using quite a few concepts we haven't really gone over yet. And the reason I haven't gone over them is because they're not incredibly pivotal at this point in the course, but Unity wants us to use them for some reason. We can go over here. If we go here, we can see we just said collision.collider, activating whatever colliders in there, .compare tag, checking the tag is ground. But when we use trigger, we have to type a much longer line of code that goes like this. If collision.getComponent, open brackets, and we're going to say polygon collider 2D, because that's the type of collider we'll be using for our enemies. Then we're going to put parentheses, dot, tag, compare tag, another open brackets, and then obstacle. Now, you might be going, what in the world did we just write? And I don't blame you, because this is using all sorts of concepts that I didn't want to teach at this point in the course. And I don't actually know why Unity makes us use all of these concepts for such a simple line of code. In my opinion, I don't understand why it can't just be collision.collider.compare tag just because we're using a trigger. But for whatever reason, Unity wants it like this. And I tried in a previous take of this video to do it the other way, and it causes all sorts of problems. So just copy the code exactly as I have, and don't worry if it's a bit confusing. We'll do collision.getComponent, open or less than sign, then polygon collider 2D, greater than sign, open bracket, close bracket, dot, compare tag, open bracket, quotation mark, obstacle, quotation mark, close bracket, and then we're going to write in our if statement, state equals to dead. Now, the first thing we're going to do to check if this works is we're actually going to make it so that our collider, we're going to make a new collider, a new object, and call it obstacle, and see if we stop moving when we hit it. So we're going to go over here to the course assets folder, and we're going to click the triangle and drag it into our scene, like so. Now, the first thing we're going to do is we're going to scale that triangle down, move it to about there, and I'm going to make mine red. There we are, that's a decent color, darker red. Match the rest of the scene. There we go. Now what we need to do is we need to make sure that when we collide with this obstacle, we trigger the dead state. But obviously this obstacle doesn't have the obstacle tag. So to change that, we need to go here, you go add tag like we did last time, and type in obstacle, exactly how I wrote it, capital O. Then we'll go over here, we're going to click, sorry, not the player, the triangle. We're going to click here and we're going to click obstacle, so that now it has an obstacle tag. But we don't have a collider attached to this triangle yet. So we're going to need to do that. Type add component, the polygon collider from earlier, polygon collider 2D, and make sure it's a trigger. You can see that's perfectly around our triangle. Now, if we click play, it should reload our script assemblies, and then we should move. If we go to our player, perfect. As soon as we collide, the dead state is triggered. And this is actually going to be the start of a really another big step in our game development journey. We have just created a sort of mini state machine. And this mini state machine allows us to track when the player is dead or alive. And I'll show you how easy it is to expand on this in the next episode. But if your code has worked like mine, great job. As always, I'll link my original code in the assets of the resources of the video if yours didn't work. But good job, everyone. Should be working perfectly fine. And I'll see you in the next video. Hey there, and welcome back to Unity. Now, in our last episode, we created our very first state machine, which allowed us to, when playing the game, have the player in two different states, namely playing when it doesn't hit the obstacle and dead as soon as it's hit the obstacle. And this might not sound like a very big change, but this is actually really good. And it's a really big step in our game development journey because it's going to do a lot of the work that we need to make our game loop working. And a game loop, in simple terms, is basically anything that allows us to play a game over or win and lose and retry. To explain it another way, you can think about a game loop as a process to make sure that the player doesn't have to restart the app every time they want to start the game again. So obviously in our game now, if you play our game and you lose, namely if you hit the obstacle, the only way to carry on playing, obviously, is to restart the game. And we want to change that. So first thing we're going to do is we're going to go into our state manager script. And actually throughout this entire episode, we're only going to be editing this state manager script. So I'm going to upload an updated version of the state manager script at the end, but we're going to be editing what we had from last time. So double click on state manager. And when that loads, you're going to start by creating a new procedure. So you're going to go over here and you're going to type public void die. And this very gruesome name for a procedure is basically going to be the code that we run once the player is dead or has a dead state. So you can see over here, where as soon as we collide with an obstacle or died, we just set our state to dead. But we actually want to call this dead procedure and then do all of that setting inside this procedure for various reasons. The primary one being that this way we can add death effects or add a timer to respawn, which we're also going to do in this episode, all sorts of things. So we're going to go ahead and cut that code and paste it over here. And I'm actually going to change this to a capital D because I think that looks better if it's capital P and a capital D. Then over here, I'm going to call the die state, parentheses and semicolon. And now, sorry, the die procedure. Now, when we hit an obstacle, we're going to call this procedure. I'm going to set my state to dead, and everything should work just as it has been this entire time. You should have a working program that does the following. We should run, go along just like last time. As soon as we hit that, we should stop moving, just like we had it before. So what's actually cool about this is we can now, from this procedure, call a respawn procedure. So if we go down here and we go public void, and we're going to call this one respawn, put parentheses, open. And our respawn procedure is going to set us back to the position we want to be at the beginning. And we want to make sure we go back to our spawn point or starting position. And so I'm going to set that starting position to be where I want to start the player. So I'm going to move the player down here, and I'm going to say, okay, this is a good starting position. So it's minus 8.52 and minus 1.69. So go over here, and we're going to go transform. Like, remember in the camera script how we referred to transform being the game object attached to the script? Exactly the same thing here. We're referring to the player's transform. Dot position equals, and once again we're going to use a vector 3, new vector 3, open curly brackets, normal brackets, and we're going to type in minus 8.52 and 1.69, and of course 0. Now this should all work perfectly, but we can see over here it says cannot convert from double to float. And this is basically because we haven't told Unity that what we're storing here are decimals. We've just said, oh, these are just two numbers that we put dots in. And Unity is going to automatically get confused as to what they are. They're going to think, oh, is it double, is it float? So to minimize this, we're simply going to put the letter F, lowercase f, after both of these. And Unity will then know that these are two floats and we are good to go. Now, before I go back into Unity, I actually have to make sure that I call this respawn code from the die code. So I'm going to go here and I'm going to call respawn, meaning that as soon as I die, I set my state to dead and then I respawn. And what this is actually going to do is it's going to make me respawn, but I'm still going to be in the dead state. And that's going to look somewhat like this. I'm going to go, travel along, travel along, travel along, travel along, die, and then go back here and still be in the dead state. You can see I'm not moving because I'm in the dead state. But we don't actually want that to happen. We want to carry on moving. So we're going to go set our transform, and then we're going to set our state back equal to playing. And this is our very first instance of what a game loop is, because now we can see if we hit play, we can move along, move along. If we die, we respawn back to where we were, and we can play the game, in effect. If we jump over this, which I failed to do there, I'm not going to do. I don't even know if this is possible, because I'm traveling at like half a mile an hour, but yeah, it's not. But if we made our player speed over here, if we made my speed something like 4, and then I jumped at the right time, I could actually go over that, and I could carry on playing. Obviously now I'm going to run into trouble, because we haven't finished building the map, but that is the basics of a game loop. And actually, the last thing we're going to do in this episode is we're going to change the speed to 3, because 2 is just a little bit slow, even for testing purposes. And yeah, so if you have everything working just like I do, you've made your very first game loop. Now, the only thing we need to do in the next episode, we're going to add a slight timer so we don't respawn immediately. We die and then respawn. And that's actually where our state machine is going to come even more useful. But I'll get into that in the next episode. What you should have now is a normal respawn script. And if it's working perfectly, good job. Hey there, and welcome back to Unity. Now, in our last episode, we created our game loop, which is another very big step towards our mobile game being completed. And if we click play, we can actually see it in action here. What we made last time, we'll move along, and the minute we die, we go back to the start, which is really, really cool. Now, there's a few problems with this, however. First of all, there's no time delay because we spawn practically as soon as we die, which isn't ideal. And second of all, we are spawning a little higher than I originally intended. And when I was watching the video back, I realized I entered the wrong value. I entered 1.69 instead of minus 1.69. So the first thing we're going to do in this course is we're going to go ahead, in this episode rather, is we're going to go ahead and fix that. So I'm just going to go back to my script, which I made last time, and add a minus. Now that should look a little bit better. But our problem earlier of spawning as soon as we die is still one that needs to be solved. If we hit play right over here, we'll see that we are traveling along. We spawn now lower down, but we still spawn as soon as we die, which isn't great. So to fix this issue, I'm going to introduce a timer that gives us a little time delay from when we die to when we spawn again, so we can actually see our state machine in action. So I'm going to go ahead, still open up this state manager script, and I'm going to do, this is quite a simple process, but it's going to be using a very unfamiliar term and procedure called an IEnumerator. Now, IEnumerator, if I go over here, write this down, it works in a similar way to a procedure. I'll call it delay, put parentheses, and then put brackets. Now, to be entirely honest, I used IEnumerators for a very long time, not knowing what they did, just as time delay commands or wait commands, and that is perfectly okay. IEnumerators are a little bit more complicated than that. They have to return a value, as you can see. It's a bit of an unfamiliar thing for us at this point in the course, but for now, all you need to know about them is they're the tool we're going to use to delay. And we're going to write code that says yield, return, new, wait for seconds, open brackets, 1 semicolon. And then we're going to call the respawn procedure, like so. Now, the last thing we need to do is, instead of calling respawn directly here, we're going to call start coroutine, open bracket, delay, parentheses, and then a semicolon. Now, you might be thinking, what the hell did we just program? And I don't blame you, because we just added a completely unfamiliar thing and then a completely unfamiliar command. But I don't really want to get into every single use of this thing, because this is not really that important in our course. In fact, you can make mobile games just using these as time delay commands, And for my first mobile games, that's all I did. So all I'm doing here, you can think about it like I'm just calling a procedure, and the procedure is then calling another procedure. The only reason the procedure looks different is because it has to be used to wait for a while. And I don't want to get into the whole logistics of that now because it's going to get quite complicated and it's not very useful. Just think about it like start coroutine, which basically is just fancy word for start procedure that can wait, then have the procedure that can wait, and then start my new procedure. So this code might look a little bit unfamiliar. Like I've said before, don't worry about it. If you write it down just like I have, it should work perfectly fine. And we're not going to get a whole lot more into IE enumerators because it's a bit more complicated than we need to. If I go back into my game now and I click play, we can see I should move along, die, and then after a second respawn, which is a lot better than what we had before, which is great. If you've got that working, good job. This was quite a short episode because I just wanted to introduce the subject of timers, but like I said, it might be a little bit unfamiliar. Don't worry about it. Just make sure that your code is working like mine is. I'm obviously going to upload my code as I have been doing this entire time, so you can download it if you have a problem. But if it's working, good job, and I'll see you in the next video. Hey there, and welcome back to Unity. Now, over the last few videos, we've created a semi-functional mobile game where you can move along, if you die, you respawn, and you can jump over this and carry on going. But the problem that arises if you jump over the triangle, you can't do anything to stop yourself inevitably falling into the abyss. And that's because the map ends over there. And in this episode, what we want to do, we want to create a map that goes on forever. Now, there are two ways to do this. One, we could just make this part of the map move with the player, so we kind of always, as the player moves, the map will do the same, then we never run out of map, but that's quite boring. What we're instead going to do is we're going to create a system which spawns parts of our map for us when we reach a certain point. If I reach there, it'll spawn a new part of our map for us, which is really, really cool. And the reason this is so cool is because it allows us to have a varied infinite map. So we can change the height they go, we can change the length if we want. Obviously, we'll add all of that later on when we approve our mobile game. But for now, we're just going to make it so they all spawn in front of us so we can have an actually functioning map. Now, the first thing we're going to need to do is we are going to need to make this map segment smaller because I think map segments should be about that big. Let's make it so the triangle just fits on. And then the second thing we need to do is we need to actually make this map segment into a prefab. Now, what a prefab is, you can kind of think of it as like a stamp. So I want to copy everything in this object, make it into a file, which I can then put in my game. So the way I do that is actually just take this floor and I drag it into the assets folder and I let go. And it creates a prefab file for me. And then I can drag this prefab file into my scene and spawn it just like I want to. We're going to be doing this with code, but this is really cool because then if I go ahead and I change something about this, for example, making this light yellow, weird olive color, it changes all the prefab. So I can actually update this however I want to, and everything will update with it, which is really, really cool. Obviously, we need to make the code that actually spawns these, but before we do that, we're going to first add another collider. Now this part's very important. We're going to go into our prefab and we already have a box collider, but we want to add a trigger collider. And we're going to go ahead and add an edge collider this time. This is going to be edge collider 2D, and it's going to, you can kind of see a green line. That's our edge collider. Then we're going to click on this button here that says edit collider, and we're going to click it and we're going to drag this side over here where the box appears up to about there, I'd say. As long as it's about maybe 2/3 of the length up, that's fine. And then we're going to go ahead and uncheck this points menu, and we're going to copy, we're going to change this to 1 so it's easier to store. And then we're going to copy element 1 to the same position. So where they're both stored over there. And then last thing I'm going to do is just move that slightly up, make sure this is 1 still. So what I've basically done there is I've moved the 1 point, gotten the X position of that point by unchecking this points menu, and then just simply taken it and copied it across, and then made the Y values so that they look like a wall that you can't go through, which is exactly what we want. Now, obviously, if I played it now, I would go there and I would stop, wouldn't be able to go through. So if I make it a trigger, I'll be able to pass through perfectly. But this does actually create a few problems for us. I remember earlier when I was editing one of our previous scripts, I believe it was this state manager one over here. We can see we have an on-trigger event. And if you remember me saying, I remember me saying that this was a very, very complicated way of getting where the tag of the object. And I was right. It's very stupid and it was not actually what we need to do. So Unity doesn't actually require us to write this entire line of code. We can actually take out everything here and replace it with .gameObject, .compareTag. And that will do the exact same thing for us. And the reason this is so helpful is because that previous way was getting the collider and then getting the game object, which was just a little bit tedious. This way is a lot more simple because then we can just get the game object. So I want you to go ahead into your state manager script and change that to .gameObject so it all works perfectly. You could have left it like it is, but trust me, you'll run into problems later. It's not worth it. Just change it to .gameObject and everything should work fine. And then we're going to, in our new script, we're going to do something very similar. But first, let's just test that that works. If it does, we should be able to die just like we have been and respawn. And you can see it works perfectly. So go ahead and make sure you change that to collision.gameObject. The reason I thought it was the more complicated method was because in a previous take, I had written it in a similar fashion to this, and Unity had told me that that was deprecated and old. So I assumed that was the only way to do it, but I guess there was another simpler way. So my apologies for that. But yeah, just make sure you fix it to collision.gameObject.compareTag. That's a lot simpler. Then we can actually go ahead and make our new script. So we're going to right click here and we're going to go create C# script. We're going to call this map spawner. And we're going to actually add this script to the player. The reason we're going to add it to the player is because we want to spawn the map relative to the player's position. So if I go ahead and drag that onto the player like so, we can see I have my map spawner attached to the player. And now when I reach points in my code where I want to spawn a map piece, the player will pass through it and it will spawn a map piece in front of the player, which is exactly what I want. So the way we're going to check where we're doing it is with this collider we added. Obviously we have a trigger collider. So we're going to say whenever the player goes over that trigger collider, spawn a new piece of the map, which is perfect. I'm actually going to go into my code over here where I'm going to go to the state manager code and I'm going to copy this on trigger event exactly like it is. Copy it. Then I'm going to open up my new script, the map spawner script. I'm going to delete these and I'm going to put it there, void on trigger enter 2D. The only thing I'm going to do over here is I'm going to change this tag from obstacle to ground. You'll remember that was the tag we made for the ground earlier. And I'm going to delete this procedure and replace it with my instantiate procedure, which I'm going to make in a second. Now that I've briefly gone over what prefabs are, I'm going to show you how to spawn them via code. So what we're going to do, we're going to go to our script over here and we're going to go and create a new variable, public, and we're going to create a reference to a game object. Now I remember we did this earlier with our camera follow script where we first made a game object and then changed to a transform because we realized we didn't need a game object. But the great thing about game objects is we can actually store all entities in Unity scenes as well as other asset files which are objects like prefabs. So we can store prefabs in game objects and then spawn them in via code. So if I go public game object and I call it floor, then I go over here and I change this code and I make it capital G game object space and then put it whatever I want to call it. I'll call mine floor piece. Then I'll put an equal sign. Then I'll write the word instantiate. I'll open parentheses, I'll type in floor, the variable this time, then I'll write as, and then again a capital G game object. Now you might be a little confused as to what exactly we're doing here, but basically what this line of code is saying, okay, we have this variable over here, which we are going to link to floor. If we go here, scroll down and drag floor in, now there's a link between them. So our floor is this object. We're going in our code now saying, okay, when we collide with a trigger that has the label ground, in other words, when we pass that point, I want to instantiate, which means create, floor as a game object and store it in this local variable. I remember we went over local variables long ago in our introduction to C# video, but basically they're just variables that you can reference in just this method. And because we're going to be making the entire object in this method, that's perfect for us. Basically what this line of code is going to do is going to put it somewhere, but we want to control where it goes. So under the scene, I'm going to go floor piece dot transform. Remember that's its position, rotation, scale, dot position equals new vector 3. And then I'm going to want to put in the 3 positions where I want our transform to be. Obviously, I know I want my Z to be 0. I'm going to set them all to 0 for now. I want my Z to be 0. And I want my Y to be something on the bottom half of the screen. But my X, I'm obviously always going to want to be different because if I'm moving along, and then I want to spawn something, if I always entered, say, this value, -4, and move along, it would spawn in the exact same place. Or even if I entered a value like here, -3, as I got to that one, the prefab which would have this trigger as well, I want to spawn the third piece, it would put it in the same place, which isn't great. So I actually want to spawn it relative to the player's position. And we're going to do that. We're going to find the offset, just like we did with our camera follow script with variables again. So I'm going to go back here and I'm going to type public int offset. And I'm actually going to go ahead and type a y value similar to this one, so they all spawn with the same y value. So if I make this minus 4.6417, I'm going to put that in my y value. And then over here, I'm going to say, oh, don't forget to put your f in so that it knows it's a float. Then over here, I'm going to say transform, lowercase t, meaning the transform of whatever this is attached to, in this case, the player, which is perfect, dot position, dot x, plus offset. Now what this is going to do, these two lines of code are basically going to say, okay, when I collide with something, when I trigger my event that means I want to spawn a new piece of the ground, I'm going to make a new variable, local variable, and I'm going to call it floor piece. And that variable is actually going to create a new object for me and put it in the scene. And then this object, I am going to put at a position minus 4.64y, which is around there in our scene, 0z, and then wherever I am, plus a certain value. You can actually see that in action. If I just go ahead simply here, and I put in the value 5 for the offset. I don't know if this is going to work. It might be a little too close, it might be a little too far. That's why we use variables, but I'm going to try it out. If I go along here, we can see that it is actually way too close. We can see that these two are actually overlapping over here by quite a bit, but we are creating a map just like we want to. So I'm going to go ahead and change this to something more like 10. Let's see what that looks like. If I load my game back up again, we can see that I'm creating a map piece almost perfectly right afterward, which is pretty cool. But I actually want to make the player a little bit faster, and I want to make these map pieces also a bit further apart. So I'm going to change this to 12, and then I'm going to change my player speed to 5. And what should happen now is I have a map which I can jump across a lot easier. I'll be a lot faster now, you can see. And I have to jump across and hit it so that I land on each new map segment, which is really cool because the map's going to be created as we move along, which is really, really cool. And we can actually start making our map more interesting. But before we do all of that, we actually need to make a little bit more code to make sure that we're not clogging up our object inspector. So if we go over here, our hierarchy, we can see the floor clones are being created. These floor clones are the prefabs being instantiated into our game. We can see they're just filling up and they're not being destroyed. And I don't need this anymore because I am not using it anymore. So what I'm going to do is I'm going to make a new script, and I'm going to say when my position, meaning the position, I'm going to attach the script to this floor piece, to the prefab. And I'm going to say when my position is less than that of the player plus a certain amount. So when I'm this much further away from the camera, destroy myself. And that's going to be a very simple script. I'm going to right click, create C# script, and I'm going to call this floor. Then I'm simply going to go ahead and open up floor. And I'm going to say in the update clause, first thing I need to do before I do that actually is I need to create a new variable so I know what the public transform of the player is. So I have a public transform, just like we used for the camera follow script. I will call this one player. Then I'm going to go ahead here and I'm going to say player.transform.position.x, and that's going to be my one thing I'm going to store. Over here I'm going to say my transform.position.x. Now over here I'll say if my current location in the x plane is less than the player's current position in the x plane, I want to go ahead and destroy myself. And the way I'm going to do that is I'm just going to type destroy like that, open brackets, and then lowercase game object. This is basically saying destroy myself, because the lowercase game object is referring to whatever game object this script is attached to, in which case we're talking about the floor, this prefab. So what this is going to do is when my position is less than that of the player, destroy myself. But I'm sure that you can figure out that the x position of these floor pieces is going to be less than the player when they're about there, but we don't want to destroy it yet because we still need this floor. So what we're actually going to do is we're going to say when my position is less than the x position of the player minus and then another offset value, and we're going to make this one minus 10 because it doesn't have to be exact, it just has to be a little bit more leeway so that we know we don't destroy it as soon as we pass it. If this works, what should happen is that every single frame, we should be checking if we are too far away. And if we are, we should destroy ourselves, which is going to save performance in the long run, which is really, really good. So I'm going to go ahead and go to my floor prefab over here. I'm going to click add component, and I'm going to write the name of the script I just created, floor, and we can see it's actually over here. We can add it there, and then I just need to add the player transform. But it's not that simple. Because this is a prefab and not a game, we can't just drag in our player transform just like we did before. We actually need to assign this via code as well. So we'll go back here, we'll type void start, which we deleted earlier, but we can just get back by doing that. And then we'll say player equals. And this is going to run as soon as we're instantiated. So as soon as we create it, we'll go capital G game object dot find, which means search in the editor, open bracket, and then we'll put quotation marks and call this player, because we can see that our player is called player. We're actually going to be searching the editor now, dot transform. And this is going to say, okay, when I spawn, look for a player, game object dot find, meaning search for the player, position, and then, well, not exactly position, but that's a simple way of saying it, position, and then put it in that variable. And now, if that has worked, what should happen is we should start our game. We can see that as soon as we create a floor piece, we can pause the game and we can look over here. And this floor piece actually has assigned the player transform to it, so our code has worked perfectly. On top of this, if we create a new floor piece, we can actually see the old floor piece gets destroyed pretty much exactly when we're done out of screen, which is perfect, because it means that if you look on the screen, you can't see any issue with it. It's kind of working perfectly. But as we're doing it off screen, the floor piece is actually being destroyed, which is really, really cool. The last thing we're going to add is, because these floor pieces are being created right in front of us, that looks a little not great. It doesn't look too cool. And what we want to do is we want to make it so that they're actually installed 2 ahead of us. So we want to take this floor piece and we want to say, move that 2 ahead. So the way I'm going to do this, I'm going to go to the player and I'm going to change this offset to something like 30. And then it will be, or rather 24 actually, that's exactly double. Once we've set this value, we're just going to do one more thing. We're going to go over here, and instead of having 1, we're going to put 2 at the start of the game. Because as I'm sure you're thinking, if we put 1 there, it's going to spawn 1 too far away for us to jump to, which isn't going to work. And now, if we play the game, we should be able to find a sweet spot for where we want this to spawn without having to jump too far. So if we hit play, we can see it gets spawned perfectly where we want it to, and there's always map to jump to. There's slightly bigger gaps sometimes, and slightly smaller gaps sometimes, which is our own little innovative, creative take on this game. The reason these gaps are happening is because of our 2 starting things not being exactly 24 units apart. So obviously, if you want, you can move this around until you get less gaps or more gaps, whatever you want. I'm going to leave mine for now. I'm going to put mine about there because I think the gaps actually add a little character to our game. And if we carry on here, we can see we have a bigger gap and a bigger gap. I've kind of minimized the issue a little, but they all look fairly similar. So if you want to use my coordinates, you can. They are minus 4.8988 and 8.38, which is pretty good in terms of not getting a gap. But what's really great is that we've actually taken a huge step again towards our mobile game being done. Now we have a game loop and an infinite map, which means all that's left to do is make some kind of obstacle that spawns on all of these, obviously with a little bit of variety, which we'll be doing in the next episode. And we have a mobile game, which is practically done, which is really, really great. Now, I understand this was a bit of a complicated episode. I'm sure that a lot of the concepts we went over in here were a bit confusing, especially with these instantiating prefab business. So if you need to watch it again, I completely understand. If you don't want to watch it again, that's also fine, because we're obviously going to be covering these concepts a little bit in the future when we, especially in the next episode, when we're going to instantiate triangles, make them prefabs as well, and also put them on these block floor pieces just like we need to. But we'll get into that a bit later. If you've made it through the episode and yours works perfectly fine, great job. If you need to download my code, that's fine too. Just make sure you copy it exactly across and you should be fine, have a working game. Great job everyone, and I'll see you in the next video. Hey there, and welcome back to Unity. Now, in our last rather long episode, we made our map generation system, which is really, really cool. It's another massive step to making our mobile game a reality, because now we have an infinite map which we can traverse when we play the game. If we go ahead and load it, we can see it in action, just like we did last episode. The map is generating in front of us, and I think we might fall. Oh, we actually make it across. We can actually see this map in action over here, making our new segments and destroying the old ones, which is really, really cool. Now, in this episode, we're going to want to improve this a little bit because while this is a very, very nice map generation system, the map that we're generating isn't the most interesting thing in the world because we don't have any triangles, obstacles. We just kind of have green floor pieces being spawned one after one another. And this isn't ideal because it doesn't give us a game to play. It just kind of gives us green floor pieces to jump to. And as we just proved, we don't have to jump. So we're going to start this episode by adding in spawn points on either side of the green floor pieces. And then we're going to create a system where we spawn triangles either on the one or the other or both, so that we have some variety in our map. Then, once we've created our triangle spawn system on either this, with our spawn points, we are then going to get started with a few issues that are going to arise as a result of us adding in triangles. Because I'm sure you're thinking, if we add in triangles and we lose, we're going to respawn, then there's going to be no floor to jump to because we destroyed it all. So we're going to create a system where we create a floor and we're going to actually spawn all of the floor pieces underneath a parent object. And then once we die, we're going to be sure to clear that parent object to make sure that we don't have duplicate floors being created after one another. And on top of that, then we are going to finally make this similar system with the triangles because we want our triangles to also be child objects to the floor. So we're going to add that in afterward. And from then on, we will be able to have triangles and floors, so we don't delete the floor pieces without the triangles. And we're going to be able to restart the game while clearing everything. We're going to get started with the triangles first. If we double click our floor prefab, remember this is what we're spawning in. This is our stamp. And we go over here at the top. We can actually create child objects just like we did with the environment long ago. When we made that environment object and added a bunch of child objects to it, that's what we're going to do here. So if we go right click and we go create empty and call this pos for position 1. We can make an object that we place on this floor, and then no matter where we put the floor, that object always stays the same relative to that position, which is really, really cool because this is going to allow us to make spawn points for the triangles. So I'm going to put one over here about maybe a third of the way, and then another one over here, maybe about 3/4 of the way. So we can see over there our 2 spawn points. I might have to adjust these as I go along, but they're fine for now. And these spawn points are going to be where I'm going to put my triangles. So I'm going to make a script now that says when I make this floor, I'm going to generate a random number, and it's going to say either put 1 there, or 1 there, and 1 there, which is really, really cool. So if I go ahead into scripts, I'm going to right click and I'm going to go create C# script. I'm going to call this one triangle spawn. And I'm going to go ahead and I'm going to go to my floor and drag my triangle spawn script onto my floor like so. There we are. Now my triangle spawn script is obviously empty, so I'm going to open that up. And I'm going to go ahead and delete the update method, but keep the start method because we're actually going to be doing all of our coding in this start method. Now, this is going to be a rather simple script because we have actually handled instantiating before, and everything in this script we've actually done before as well. So if I go, I'm going to first start by making my public transform, call it position 1. Then I'm going to make another one. Now I could type the exact same line again like this, public transform position 2, but a simpler way of doing it is just putting a comma and then writing position 2. And that's basically the exact same thing, saying public transform and I want 1 core position 1, 1 core position 2. If I go back into my Unity editor and I open up my floor script, or floor object rather, I can see position 1 and position 2 are here and they have not been assigned. Now you'll remember we couldn't just drag the player in because the player was an object and this is a prefab, so it's not that simple. We had to write code to get the player in our last episode. But with the floor, because we are assigning prefabs to it, we can drag it in just like normal. I'm actually going to rename this from position 1, 1 to position 2 just so it's a little nicer. But yeah, we can actually drag those right in, which we couldn't do last time, which is really, really cool. Because now what we can do is we can go ahead and make our spawn script for triangles. Obviously, we're going to need to use a prefab, just like we've been doing this whole time. So I'm going to go public game object, call it triangle. And then we're going to write very similar code to what we did over here. This game object floor piece is instantiate floors game object and the transform position. That's actually going to be the exact code we're going to write over here. But this code, there's going to be a few conditions as to how many and where we spawn them. So if we think about this logically, there are 4 combinations which we can spawn. We can either spawn 1 triangle on the one side, 1 on the other, 1 on both, or 1 on neither. And we could do this by writing 4 if statements and obviously then doing a condition for every single one. But we're actually going to simplify this by just making 2 if statements. And the way we're going to do this is we're going to create a random variable which sets x to be 1 or 2. So I'm going to go int x, so it's a local variable, equals random dot range, open normal brackets, and I'm going to enter one value, in this case 1, and another value, in this case 3. And this is actually going to give me a random number from 1 or 2, not including floats. So either 1 or 2. If, for example, I put an f here, it's going to give me a random float. So it's either going to be 1 or 1.1 or 1.2, 1.3. But obviously that's going to give me a few issues here because I'm storing an integer. So I'm not going to do that this time. I'm going to store a random integer from 1 with a maximum of 3, but that's actually going to be 1 or 2. If I make this void update, so it happens every single frame, and then I go print x, I can actually demonstrate this process because this is going to be printing my x variable every single frame from 1 to 3. And we can actually test if this is in fact the random variables we want, because this is going to run every time this code is starting or every time a floor piece is instantiated. So if we go over here, we'll see right from the start, we have a bunch of 1s and 2s and no 3s, because this might be a little confusing at first. I don't know why it's exact like this, but for some reason in Unity, when you say 1 to 3, it means that's the minimum and this is the maximum, not including the maximum. So 1 or 2. Now this 1 or 2 variable, we're actually going to set random twice. So the first time we're going to do it at the top where we assign it, we say integer x is random range. And then a few lines down, we're going to do the exact same thing so that we have another random variable. And then over here, we're going to have our first if statement. If x equals 1, do this. And that's going to be if x is 1, spawn my 1 prefab. Then we're going to reassign x and we're going to do the exact same thing. If x equals 1, then do that again. And the way this code basically works is it picks a random variable value for x from 1 to 2. Then if it's 1, do this, spawn the 1, does it again, and if it's 1 again, spawn the other. So we can see from this, we can either have 1 triangle or no triangles, or 2 triangles, or 1 triangle in the other position. Obviously, so there are 4 different combinations that can occur from this, which is really cool. And then the last thing we need to do is simply make the code for spawning in this triangle. And like I said, this code is going to be very similar to this code. We can in fact copy that code and put it right there. But obviously it's going to give us a few naming issues. It's like, what is floor? So we're going to change that floor to triangle. And obviously we don't have an offset variable either. And this vector3 transform isn't actually what we want our transform to be at all. So go ahead and remove this part of the code. So now we have game object floor piece is instantiate triangles game object. Doesn't make a whole lot of sense. So let's change that to triangle. Then we're going to have to type it here as well. And now we've got game object triangle. Oh, we've seen a naming error. Now, the reason this occurs is because we're naming this triangle the same as we're naming that triangle, which isn't good coding logic. So we're going to go ahead and make that a capital T and a capital T. And now we can see that the error actually goes away. This is a good thing to illustrate in C# because C# is a case-sensitive language. And we also showed 2 concepts there. One, that you can change the case and it's a completely different thing, like we've seen with capital game object and lowercase game object. And also that you can run into naming errors in C#. Now, over here, my triangle.transform.position, I'm going to want to set to either position 1 or position 2. So over here, I'm set to position 1 because that's the first time I spawn. But position 1 isn't actually a position, it's a transform. So that's a transform, that's a position and a scale and a rotation, all sorts of things. So I'm going to have to type dot position over here. And that's going to give me no errors at all. Then I'm going to copy this exact code and put it down here, except this time, simply change this to position 2.position. Now, this is a bit of a tedious way of writing this code, but I thought it would be best to illustrate the logic of what we're doing. There might be some ways you can simplify this if you show this to a professional C# developer. There might be, oh, change that, you can do it in 3 lines. But for now, it's actually going to work completely fine. Now, we could go back into Unity and test this code, but we might actually realize that we have forgotten to change this back to start. We were trying to illustrate something earlier with update, but if we run this code now, every single frame is going to be spawning more triangles, which isn't at all going to be what we want. So make sure you change that back to start. I don't know if you changed it to update when I did, but if you didn't, that's great because it's meant to be start. Now, go over here back to Unity and we're going to go to our floor prefab and we want to assign a triangle to spawn in, but we don't actually have a triangle prefab yet. Luckily, just like we made the floor prefab, making a prefab is very easy. So just go back to your scene, go to the triangle and drag it in like so, and it will make a prefab for us. Then I'm going to go ahead and delete this triangle because I don't actually want it in my scene anymore. I think it's a bit weird to have one in the first one and none of the others. Obviously, they're going to be spawning in as we go, but that's fine for now. And then I'm going to go ahead and open up my floor prefab, and I'm going to want to drag a triangle over here. Now, what I want to do is I want to make sure that I can play my game and spawn triangles as I want. But the one problem with our spawning code, or not our code, rather our spawning system at the moment, is that we have two floor objects, and one of them is going to be running the triangle script as well as the other. In fact, all the floor objects are going to be. And what's going to happen in this one, we're going to start the code, and it might spawn a triangle right here, which is not going to be great for us. But if we make changes on this one, because it's a prefab, it's going to make changes on this entire prefab, which we don't want to do. So we're going to do what's called unpacking a prefab. And this might sound a little confusing, but basically all this is doing is saying, I don't want to reference to this prefab anymore. So I'll click unpack. Basically, this means now I can make changes to this prefab and not affect the overall prefab. Well, this isn't actually a prefab anymore. We've made it back into an object. So go ahead and remove the triangle spawn script from your first block. And after you've done that, you should be good to go, because we no longer want to spawn triangles on the first one, but everything else should work perfectly if our code has worked correctly. So let's go ahead and hit play and see if it does. And we can see we have one triangle spawning over there, and one there, which is perfect, exactly what we wanted. These triangles are a little bit stiff, I don't know if you can tell, and we can die and start again. You might be running into a few issues here because we haven't actually finished our game loop, but we'll get to that in the next half of this episode. Now, before we get into that, I want to first make sure that our positions of the triangles are a little better. So let's go over here and let's drag a triangle in so we can test it. Let's go to position 1 and let's copy the position. Go to triangle and go paste position. You can see it's down a little bit. So we're going to move that up, find the new Y value we want, 4.07. And we're going to actually add that to both my position 1, 4.07, and position 2, 4.07. Now, you don't need to do that process I did with the copying. I was just doing some testing. But yeah, if we run it now, it should work perfectly fine. Should be spawning triangles exactly where we want them to, and it is. We can see over there are a few not ones at the beginning, but from now on we are spawning triangles exactly where we want, and if we die, there's the same issue from before. Now, the reason this issue is actually taking place is because if you think about it, we're spawning floors all the time, but when we go back to the beginning, we're still spawning floors, but there's nothing for us to land on. And that's actually why I wasn't done with the first script. I need to actually remove this script as well from the floor, because I don't ever want to destroy the first floor. I want to destroy the floors after that, and the same with the second floor. Now, the second floor, I can keep this triangle spawn script on because I want to make sure that I can spawn triangles from here. So I'm going to remove this floor script, but before I do that, I'm going to make sure I unpack this prefab as well, because otherwise I'm going to have the exact same issue I did with the first one. So remove this floor script and go over here and remove that same floor script. And now if we hit play, we should be working pretty much fine. If we die, we can spawn back to where we started and keep spawning in things. Obviously, there are a few ones here that are already there. They're kind of spawning over the others, but the gist is there. The last thing we need to do is actually make sure that these old ones are cleared so that we know that we are clearing all the old ones so we don't have duplicate ones spawning on top of each other. And the way we're going to do that is by ordering them. So we're going to create a new object, and we're going to call this spawned floors. So I'm going to go ahead and make sure that I have this spawned floors object. And then I'm going to want to add this as a reference to my map spawner script in my player so that I can make sure I store all of my floors inside this spawned floor script. I'm going to go ahead and make that 0, 0, 0. Just like we did with the environment with our floor and our background on our floor, I'm going to do the same thing with spawned floors so that once I die, I can clear out the spawned floors and make sure all the old floors get deleted. So I'm going to do that by opening up my map spawner script, and over here I'm setting the transform.position, but I also want to set the parent object, which means I want to set the object that this object I'm spawning now is a child to. And this might not sound important, but as I just said before, we'll be using it as storage space, not so it keeps track of the location or anything like that. So go over here and set floor piece dot transform dot set parent. And you could just say .transform.parent equals thing, but Unity seems to think that's an old way of doing it. So this is the better way they want now. Open bracket. And now we need to set something in here, but we don't have a reference to the thing we want to store these in. So let's go here, public transform call this one storage. And then we're going to go here and type storage into there. And we don't need to say .parent or .position or anything like that. This knows exactly what we want to do. So we have our transform storage variable, and we're doing .setParent, which is basically a fancy way of saying put everything inside there. The last thing we need to do now is we need to go ahead and drag that into the storage. And if we do so, we should now see that every single time we instantiate a floor, it gets put inside this spawned floors thing, which is really, really cool. Because then if we die, well, I mean, there's no thing spawning now, which isn't going to illustrate my point well. If we die, what we can do, if we pause the game now, we can go into spawn floors and we can delete all of these old floors, which we don't need, which is really cool. Obviously, we haven't quite organized the triangles yet, so we'll make sure to do that later in a second, use the exact same method. But now if we go like this, we can see that the floors get spawned in the exact same way and no more duplicate floors are stored, which is super cool. Now, I'm sure you noticed the triangles were sitting on their own, so let's actually fix that up quickly. If we go into assets and we go to our floor, we can see that the triangles are spawned from this triangle spawn script. So let's go script, triangle spawn, and then do the exact same line of code we just did over here, floorpiece.transform.setParent, except this time we want to set it to ourselves. So let's go here and we'll type triangle.transform.setParent, and then I'm just going to type transform with the lowercase t, meaning the transform of whatever's running this script, because that's going to be the floor. Copy that across and put it down here. And perfect, that should work perfectly fine. If I run my game now, we can see that all of the triangles are actually spawning inside the floors over here. Position 1, position 2, and if we go over here, floor 1, the triangles are inside them, which is exactly what I want. The last part of this cleaning up code I want to do is I want to make sure that my triangles and everything else is deleted once I die. That's going to be a little more complicated. So I'm going to go over here to my state manager script, and we can see we've got this die procedure, but I don't want to delete it from here because that's going to be a little confusing. So instead, I want to go to my map spawner script and do it from there, because that makes a little more sense, like which script we're calling it from. We could do it makes no difference because the state manager script is on the player, as is the map spawner. But just for interest's sake, I think it will be easier if I did it from here so it's less confusing in the future. So the first thing I'm going to do is I'm going to make a new procedure, and I'm going to call it public void, and I'm going to call it clear storage. Then this is actually easier because I can go storage over here. I have my storage variable. I can go storage, and I can clear every single child of the storage. And the way I'm going to do this is I'm going to go dot get child, and then I'm going to want to get the child, the first, the second, the third, the fourth, the fifth. If I type 0, I get the first child. First, I get the second child. But I want to get every single one. And we're going to do that using a for loop. So I'm going to go for, then I'm going to want to call a new variable. And I don't have a variable yet, so let's make a local variable, int x. Then I'm going to say for. And if you remember the for loop syntax, this should make sense. I'm going to go over it again because I'm sure many of you have forgotten it because it was about 15 episodes ago. I don't even know. For x equals 0. So that means I want to get the first child. Then I go x less than, and now I want to do this for as many children as storage has. I'm going to go storage dot child count. That's going to give me a number. So if it's going to be 1, this code is obviously going to run once because it's 0. It's less than child count because it's going to run once, and then it's going to be 1 because I'm going to increase it at the end. I'm going to go x plus plus. Now remember, with for loops, a mistake a lot of people make is they separate their parameters using commas. So they say x less than 0, comma x plus plus. But we actually use semicolons. So make sure you have x equals 0, semicolon, space, then x less than child count, semicolon, space, x plus plus. And yeah, just remember that because that's a mistake a lot of people make. This is actually all the code we need to destroy every single one of these child objects, because we can go for x is 0, x less than storage count, x increase. So if we have 2 children, it's going to go 0, increase by 1, 1, and then because it's 2, it's not going to be less than child count. So that's actually going to work. I'm going to put x over here, storage.get child x, and we're going to go ahead and destroy this. We're going to type destroy, open bracket, storage.get child object. And if everything should work, whenever we call this state, we should clear every single one of the objects. we're going to actually want to call this as soon as we respawn. Because if we think about it, when we call if we die, we're going to fall through the floor. So over here in the respawn, the last thing we have to do is we have to create a link to the map spawn. So we're going to go public map spawner, call it map. And we're going to go over here to respawn and we're going to go map.clearStorage. Now, before we go back into Unity, we first have to make sure we're destroying the game object, not the transform, because we can see this code over here says storage.getChild, but that's going to return us a transform. So to fix this, we just simply go child.gameObject, and that's going to actually refer to the game object, not the transform component. Just know that if we say .getChild, that returns the wrong kind of thing. It returns a transform child. It doesn't return the actual child. Over here, we're getting the game object, which is the actual child object we want to destroy. So if I go back into Unity, I just have to drag this map spawner onto the map variable stored in the player to make sure they're linked. And then if I go ahead and hit play, I should see that this spawn floors is slowly getting populated by different floors. See, there's 2, and now if I die, they should all be cleared, which is really, really great because it means that this is working just as we want it to, and there are no more duplicate floors, which is really cool. Now, if you've noticed a few small errors in your game, for example, I've noticed that sometimes I can't jump on the 3rd floor or ones after that. That's completely fine. We're going to address those in the next episode or the episodes following. For instance, we've never actually controlled whether we can or can't jump when we're dead. Obviously, you don't want that to be true because it wasn't a super important part of our game at the moment. We will obviously fix all of those later. By the time you've completed this course, you will have a completely working bug-free game. So if you're testing your game now and a few things are a little iffy, don't worry, they will all get sorted out. And if you have a floor spawn script, you've done great. Now, if you followed along and your code is working just like mine is, the last thing we need to do is add a little variety to our map, and we are going to be doing so later in the course. Obviously, like I said, there are a few errors we still need to sort out and a few things we need to improve, but our basic game loop has actually been created. There are also a few balancing changes I want to address, like I don't think it's always possible to jump over both, so we're going to, later in the episodes, maybe increase gravity and increase jump force, things like that to balance out our game. But if everything's working and you have a semi-functional game which you can spawn and retry as many times you want, great job. You have done amazingly, and I'll see you in the next video. Our mobile game is going to be done sooner than you think. Good job, everyone. Hey there, and welcome back to Unity. Now, over the last 10 or however many episodes, we've created this pretty bare bones, but actually quite impressive mobile game. If this is the first or one of the first mobile games you've ever made, great job. It's actually crazy to think how much you've accomplished. You've made a mobile game from scratch using your own code, and you can generate a map, you can jump over obstacles, you can respawn, you can jump move. It's really, really great. Good job, everybody. You've been doing amazing. Now, that being said, there are a few problems with our mobile game in its current state, and you might have actually noticed them when you were playtesting your own build, and there are just a few bugs. And most of these bugs are actually logic errors, which have happened. We've done something a certain way, and then we've changed it, and then it's created a little bit of a logic error. And they're not the easiest bugs to notice, but if you can understand the concept we're doing, once I explain them, they will make a lot of sense. So I'll dive right into it. The first bug you might have noticed, if you go ahead and hit play, if I'm sliding along, you don't actually have to press jump here, you slide along. But if you do that, you cannot jump afterward. Pressing space and I'm not jumping. And this isn't a problem with my space bar, it's not a problem with anything like that. It's actually a problem with this grounded variable. You can see over here, if I'm playing, I'll see ground is set to true. And when I leave, it's set false. And when I land again, it's set to true. If I die, I'll restart. Now, if I go like this, it actually sets to false and then we can't jump. And the reason for this is because our grounded variable is based on whether we are entering or exiting a collision. So if you think about sliding over, we are going along. We enter a new collision over here and then we exit one. But because we exit afterward, that's going to override and say, okay, we're not on the ground anymore. And that's a very, very simple thing to fix. All we need to do is we need to slightly change our procedure's name. So we don't want to do it whenever we enter a collision. We want to make sure we're grounded when we're always on a collision. We're going to do that very easily. We're going to movement, open up your movement script, and you're going to want to change this on collision enter to on collision stay. And on collision stay is practically the exact same thing. It's called every single frame that we're on the ground. So every frame, as long as we're on the ground, we'll make sure that we're telling the game that we're grounded. That's stay, and just replace enter with stay. So on collision stay 2D. Perfect. Now, if we go ahead and click play again, we should see everything should be working fine. We can now jump afterward, which is great. Now, the second thing I want to address is, you'll see I'm doing all right now, but I find that sometimes when there's two spikes, it's quite hard to jump over both. And that's to do with the gravity scale and the speed of our player. That's not a bug, that's just a balancing issue. So I'm gonna go ahead and fix that right now. I'm gonna go to my player. I'm gonna actually make the gravity scale 3, so it's slightly easier to control. And then to compensate that, I'm gonna increase my jump force, but not by too much. I wanna make my jump 13. And I've actually tested this, and I've found it to be the most efficient way to fix this error. You can see now it's quite a lot easier to control when I want to jump because I'm doing it more frequently. And this does make the game slightly harder at times, but it is also a lot easier to control, which in my mind is a very good thing. So I would recommend that you go and do that because I found it to be a lot better for the gameplay. Once we've done that, you can see I'm jumping over with these with absolute ease now, which is really great. Now, the other thing I want to make sure that we do is I don't want to be able to jump or carry on moving as long as we're dead. And this is actually really easy to do as well, thanks to our state machine. So if I go ahead and I open up my state manager, you'll see that as long as I die, my state is set to dead. And the reason I stop moving is because I have a movement script here that says, if state manager.state is equal to playing, move. But otherwise, I haven't said anything else. So what's happening, if I hit that thing, I'm just no longer overriding my rigid body velocity. So I just kind of slide. I keep going because of momentum, or inertia rather, but I just keep going. So I'm gonna actually write an else statement, else. And then as long as I'm not playing, I want to make sure my velocity is always 0. I can go rb.velocity equals, and now I could type new vector2 0, but I'm actually just gonna type vector2 dot 0, and that's the exact same thing. This is just an easier way of saying it. And vector2.0 is basically going to make sure as long as I'm not playing, I am dead still. And this is really great because that means we're actually going to be overriding our movement code so that every frame that we're dead, we're not only going to not move forward anymore, we're going to stop dead in place on the x-axis, and we're going to set our y velocity to 0. So we can see over here we stop, which is really great. The problem is because we're setting our y velocity to 0 every frame, that's actually not really going to make it so we don't move at all. Our Unity gravity will still slowly slide like this. You can see over there, I'm still moving down, and that's a bit of a problem. But I can fix this very easily by just saying rb.gravityscale equals 0. You might think, oh, that's everything solved. But you have to remember to set this back to what we wanted as soon as you're playing again. So we're going to do that by going here to playing and setting our gravity scale to 3. So as long as we're playing, our gravity scale is always set to 3, and when we're not, our gravity scale is always set to 0. If I go ahead and open up my game once again, we can see that I am playing just fine, and if I die, like so, I stop, and then I'm back to my gravity scale, which is really, really cool, because I'll illustrate how this looks when we die. Much better in my opinion. Now, the third and final thing, or I can't remember if it's fourth at this point, but another thing that I want to address in this episode, I want to make these slightly shorter because I think these are a little too long. So I'm going to make these 2.8. Now just remember to change both of these individually because I unpacked them from the prefab, so they're no longer linked to that prefab. Just go into the prefab and type 2.8 over here, and that should actually fix everything else for you, which is really, really cool. Now we have a little bit more of a jump, and we have to jump across them, which is a lot better. It's like they're little islands. Now that brings us to the second last thing I want to change in this episode, and that is friction. You'll see if I go like this and I fall, I don't know if I'll be too heavy, but yeah, perfect. I'm gonna stick over here, and this isn't great. And the reason this is happening is because of my friction. Now our player's friction is set to the default friction setting, and because it's set to the default friction setting, I am basically continually moving to the right. I'm trying to now, but I'm stuck to the side. So as a result, I am just kind of staying in place. So to fix this, I am going to be making a new physics material. And I'm going to do this by right-clicking, create, then 2D, and then physics material 2D. And I'm going to call this player. Then all I'm going to do is I'm going to set this friction to 0. Then I'll go to my player and I'll drag that into my rigid body. And you can see what happens now is as I'm moving along, I should no longer stick there. I should slide right down, which is perfect. That's exactly what I want to happen. Now, we've changed quite a few things, but there's one last thing that I want to make sure that we address in this episode. And it's actually going to be a more optimized way to fix one of the things we did earlier. So earlier over here, we changed our RB.gravity scale, but we did it every single frame. And that's really not great because that means we're overriding something that's already happening. It's not good for performance. Instead, what I want to do is I want to make a procedure that's going to do it for me. And I'm going to make this with a new concept called parameters. So I'm going to go over here and I'm going to create public void. I'm going to call it reset gravity. Then I'm going to go over here and I'm going to put RB.gravity scale in here. I'm going to delete that one over there. And now I'm going to want to call this every time I change state. So if I go to my state manager, I know exactly when my state is dead and when my state is playing. The first thing I'm going to do is make a link from state manager to movement. I already have a link the other way, but I want to make a link this way. So I'll go public movement and I'll call it move. And then what I'm going to want to do, I'm going to want to call this procedure both when I die, move dot reset gravity, and over here, move dot reset gravity. But I'm going to want to set it to two different things. Over here, I want to set it to 0, and here I want to set it to 3. And the way we're going to do that, you could write two different procedures, but a much better way to do that is just by using parameters. So I'm going to go over here to my reset gravity, and I'm going to go into these two brackets, and I'm going to type int x. What this is actually going to do is it's going to say, okay, when I want to call this procedure, I have to enter a value for this parameter. It's kind of like an input value. You can see over here, it says there's no argument given that corresponds to the required formal parameter of x. If I double click this, I can see where the error is. It's over here. I'm not saying what I want to put x here. So if I enter the value 0 here and the value 3 there, everything's fine. I have now called this procedure here and given two different values. So over here I've set to 0 and here I've set to 3. And then all I need to do is go back to movement, and in my reset gravity, I need to set RB.gravity scale equals x. And now we've achieved two completely different things with the same procedure using parameters. Now this is a completely new topic, but I wanted to cover it at some point in this episode because I thought it would be useful later on in case we need it. Basically, it's like input value. So I'm telling you what to do and giving you a little bit of information to do it with, and that allows us to create a much better way of resetting the gravity. Now all this I have to do is I need to reopen Unity, go to my player, make sure I drag my movement over here, and if I go ahead and hit play, we can see now we've achieved the exact same result with a much better way of doing it. We can see we stop just like we had and we start again, which is great. So this might have seemed like a bit of a weird episode, but I just wanted to use it to teach the concept of parameters and fix all the little issues. And I think you'll find after this episode, your game is a lot more enjoyable to play. And congratulations, you finished the base module of this course, creating a mobile game. We've made a mobile game where you can play it, you have a game loop, you can win and you can lose. But there's a lot more coming, and now we get into the fun stuff. I'm sure you've noticed we haven't even made our background move with our player yet. And that's a very simple change. Obviously, I'm not going to do it now because I don't want to teach you at the end of this episode. But in the next episode and the episodes to follow, we're going to start getting ready with all of the actually fun stuff. We're going to add in our score system. We're going to add in visual improvements, audio, music, everything that actually makes a mobile game pop is coming in the second half of this course. But at the end of this episode, you should have actually finished the base core part of your game, which is really, really cool. Great job, everyone. Amazing. And if your mobile game's working just like mine is, amazing job as always. I will, of course, link all of my scripts in the description, or the resources rather, so that you can link them. And good job. Once you finish this episode, you're pretty much halfway there. The hard part of this course is actually now past you, and we're getting into the funner stuff. So great job, everyone. I'll see you in the next video. Hey there, and welcome back to Unity. Now in our last episode, we said that our game, all the core concepts were pretty much done, and that's true, but there are quite a few ways we can improve our game to make it even better. Obviously, it's not even a mobile game yet because we haven't ported it to mobile, but we're going to change all of these cool, actually fun parts of mobile game development. Obviously, the previous parts have been fun, but these, in my opinion, are the best parts of mobile game development. It's the really creative stuff you can add in sound design, improve your game how you want, all the really fun stuff. So all of that's going to be in the second half of this course, and that's going to start today with our score system. Now, before we add in our score system, I first want to make sure that our game, we can make a few minor improvements to. So starting off, I'm going to drag the background under the main camera so that I have it as a child object. And what this is going to do is it's going to make sure that our main camera is always followed by a child object. And if we go to our game here and we click play, we can see this in action. We are now followed by the background, which is really cool. It's a really simple way to fix it too. Now, the second change I want to do is I want to go to my background and I want to go ahead and I want to go add component, edge collider 2D. And then I can see my edge collider here. It's actually almost how I want it. I just want to drag it down. So I'm going to go offset, drag it to the bottom there to about minus 1.9 or minus 2 if you like. And this is basically going to act as a death wall so that if the player falls through these gaps, they die. They don't just fall into the abyss. I'm going to tag this as an obstacle and I'm going to make sure it's a trigger. And our stay machine is actually going to take care of all the rest for us. If we hit play, we can see now, if I fall through here and I fall into the gap, I in fact die and I go back to the beginning, which is really cool. Now, those are a few minor things I want to do, but obviously the main point of this episode is going to be adding a scoring system. So let's get right into that. Before we do that, we need to create Unity UI components. So we've obviously never done this before. So we'll go Window, Package Manager. We need to go here to this menu, Unity Registry, if you might be in there by default. So click here and then go to Text Mesh Pro and click Install. Now this is basically Unity's solution to text objects. It is a very powerful and easy to use tool like this over here. And it's actually pretty much the default one they want you to use. If you're not using this, then it's what's considered a legacy or like an older version. So we're going to want to use this. Then we're going to right click here. We're going to go UI Text Mesh Pro. That's going to create this and it's going to pop up this window. Click Import TMP Essentials. You don't have to add the extras. And then if we scroll up, we can see our text over there. Now, I don't like this canvas. This canvas basically acts as a storage space for all our UI components, and this is the text. If we move it out of the canvas, we can no longer see it. So make sure to keep it in there. Rename your canvas to UI. That's what I like to do. You don't have to. And we're going to rename our text to score. Then we're going to go to our UI and we're going to change this render mode from screen space overlay to screen space camera and then drag our camera in. This is my preferred render mode. You can keep it if you like, but I recommend you change it. And then we're going to go ahead and move our score to about there. Now, this does look good, but sometimes Unity has a few bugs where if you go out and back in, it's actually moved. So make sure you do that and then move it. This is the actually right position. So yeah, now I'm going to improve this a bit. I'm going to change this to font size 75, so it's quite a bit bigger. I'm going to make it bold, and I'm going to go ahead and make it a lot bigger. So we can store that there, and I'm going to drag it all the way there. And this is going to act as our score. If I type score and then enter an imaginary score, we can see over here how that looks in our game. I think it looks quite nice. We can move it a little bit to the right, and that's perfectly fine. Now we need to start coding the actual logic as to how this is going to work. So we're going to create a new object, and we're going to call this score tracker. Then I'm going to go into scripts, and I'm going to go right click, create C# script, and I'm going to call this one score. Now, this script is basically going to tell this text what to display, and we're going to work out the player's score based on how far they are from the score tracker. You'll see over there it moved, but it's actually not there. It's a bit of a weird Unity glitch. This score tracker, we want to position at the player's starting point. So I'm going to go here and I'm going to put minus 8.52, put that in the X thing, and then just move it down. The Y value doesn't really matter. And this is basically going to act as our tracker to see how far the player has moved from it or how far the player has moved, our distance, which is our score. So we go ahead and make sure that's minus 8.52 or wherever your player's starting point is, be sure to copy that. Then go over here and drag your score script onto there and then open it right up. Now, once this is opened, go to the top and we're going to import some things. We're going to use things other than system collections and generic and Unity Engine. Type in using Unity Engine.ui first of all, and then also type using TM Pro, that's Text Mesh Pro. This is going to allow us to write our script how we want to without Unity getting confused. Then we're going to create a public transform, and we're going to call this one player. Underneath that, we're going to create a public int and call that score, and a public text mesh pro, and we're going to call this text, or rather score text is a better name. Then we're going to go into our update procedure and we're going to type score equals, and now we're going to want to subtract our transform and the player's transform, but that's going to give us a float. So before we write, we're going to write mathf.round to int, and that's basically going to make sure that we can round whatever the float value is to an int. And then we're just going to go player.transform.position.x minus our, so transform.position.x, and that is going to work out our score every single frame for us, which is really cool. Then I'm going to go down here and I'm going to go score text. Now I want to store whatever this score is in this thing. So I'm going to go score text.text equals, and now I'm going to put my score value in, but I don't want it normally. I want it .toString, which means I'm converting it from an integer to a string. And this small amount of code will actually give us a score, but we want to add a little more. We want to make sure we add score in quotation marks, make sure to put it in quotation marks, a colon, and then a space. And then after that, we're going to put a plus. So quotation mark, score, space with a colon, plus, and then score. And that's going to make it so that it looks a lot nicer. It's not just going to give us a number, it's going to give us score and a colon, just like we have over here in the editor. Now, before we go back to Unity, I've actually realized we're using the wrong thing here. We're meant to use a text mesh pro U GUI. Just make sure you change that. That's just a minor thing that I forgot to add in, and that will make no issue to anything else. It's just going to make an issue to your code. Then open Unity, and you should see your score track over here. Make sure to drag your player into the transform and your score into the text mesh pro U GUI. And over there, you can see that glitch there. Just click again, it'll reset. Now, if we hit run, this should actually do everything for us. We can see our score starts at 0 and it's actually increasing just like we want to. If we die, it sets back to 0, and that's really, really cool. Now, the last thing we need to do is we need to make sure we have a high score. So the way we're going to do that is we're going to make one more variable. We're going to go public int high score. And then we're just going to have a new procedure we call over here, public void end. And we're going to say if score is greater than high score, then high score, sorry, I forgot these, then high score is equal to score. And that's basically going to make sure that as soon as we die, we check if our score is better than our current high score, and if it is, we're going to set it to our new high score. And we obviously need to call this from our state machine. So we're going to go to state manager and create a reference to this, public score manager score. Well, we've just called our score, but it is a score manager. And then over here under die, we're going to say, after this reset gravity, we're going to say score.end. And that's basically going to run that procedure. So as soon as we die, we check if our score is greater than our high score. Obviously, our high score is going to be set to 0 at the beginning. So if we go back into Unity, we just need to assign a value to our reference over here. So if we go to our player, we can see our state machine isn't assigned. So just make sure to drag in your score track over there so we can store our thing. And if you click play, we should actually have a fully working high score system. If we go here to score tracker, see our high score is 0 and our score is 14. If we die, our high score gets set to 18. And then if we die before we reach 18, it doesn't get reset, which is really cool. Now, the last thing we're going to do is we're just going to make a copy of the score text, drag it down, and we're going to call this high score. Click here, make sure you change this to high score. And then we're just going to have that right underneath. I'm going to make it slightly smaller so it's less prominent. Right underneath that, that looks good to me. And then move maybe down a little bit. And then over here, if it's greater, we're just going to make sure that we set our new public text mesh pro U GUI. We're going to make one called high score. Obviously, we're just going to put a comma like we did last time. High score text. Then over here, we're going to say high score text dot text equals high score dot toString, and then parentheses. And this is basically going to make sure that we display what our high score is every time. Now we just make sure we assign that high score. So once it loads again, put that high score in. I'm going to rename mine to high score so I know exactly what it is. And that should work perfectly fine. We have that glitch again, but that's fine. Go back into our game. And we can see our high score is 453 at the moment because we're not overriding it. If we crash, then it's set to 18. And if we go more than that, we can see it is now 27, which is really cool. Last thing we need to do is add that same text we had over here. Make sure to copy that across so we have score plus high score, and then we just change this to high score, and then everything should be working perfectly fine. This short code over here will actually do all of our high score for us, and with that small method call from the state manager, which we've linked, everything will be working perfectly fine. So just go ahead and open it up. And if we run, we can see our high score is currently 453 because that's what I entered it at. And if we do that, high score 18, keep going. Let's try and get past 18 this time. We're only at 29. If I die, it is 37 and it saves. And if I go to 18, it's not going to overwrite, which is really, really cool. It's another great step towards the right direction for our mobile game. So great job, everyone, and I'll see you in the next video where we're going to cover saving so that our high score is saved even when we close and reload the game. I'll see you in the next episode. Hey there, and welcome back to Unity, or in this case, Visual Studio. Now, in this rather short episode, we're just going to go over a quick saving system for our game. To start, open up the score script you created, just like I have now. Now, over here, we can see score is mathf.roundInt player.transform. That gets our score, and we can have our score text being assigned here. We also created this high score variable, which is basically going to check whether we have a high score or not, which is really, really cool. And it's really, really simple to make sure that we can save this high score when we quit the game and we can get it back once we load it in. And that's using something called player prefs. Now, Unity has this built-in system for saving, and we can use it for mobile games because while it does store locally on the device, no one's going to be able to encode that because it's going to be on a phone, so it's great. So over here, we have a system to see if our score is higher than our high score. So underneath this, we are basically assigning our high score, and this is basically saying, okay, you got a new high score. And if we got a new high score, we're going to want to save that. So we'll type in capital P, player prefs, dot, and then set int. And now we can basically put whatever we want to call our integer inside these brackets. So I'm going to name mine score. Then we'll put a comma, and then we put the value that we want to put inside score. So I'm going to type in high score. So we can see we are saving our high score in this score player prefs. And then over here at the top, we're going to say void start. Under start, when we start the game, in other words, when we start playing again, we're going to make sure that we get that integer variable and set the high score so that we know what our high score is. So over here, we're going to say player prefs dot get int, open brackets, score. And that's basically going to return whatever we put inside score. And I'm going to go ahead and set high score equal to that. And that's going to be really cool because now at the start of every game, we're setting high score to whatever we saved it as every time we get a high score. Underneath this, I can simply say high score text. We can actually just copy this line, in fact. Drag it over here, high score text. And we are now setting the high score at the start. We are showing what it is. And with these simple, 3 lines of code, obviously we could also add player prefs.save at the end. Doesn't actually do that much in my experience. I've found that it saves even without this, but if you want to, you can do that. I don't know, maybe it's something that I haven't run into that it saves, so maybe just put it there for good measure, but it's not actually essential in my experience. Then with these 4 lines of code, we have actually created our very own saving system. We have our high score saving every time we get a new one and reading it back every time we start the game. And this is actually going to work perfectly. Now in the next episode, we're going to go over all the visual improvements. And after that, we'll go into all sorts of other things in our game. But it's really good to have this crucial saving system set into our game with such a simplistic manner. Hope you enjoyed this really short episode, and I'll see you in the next one. Hey there, and welcome back to Unity. Now, in this episode, this is going to be one of the coolest things we're going to add to our mobile game. We are going to improve the visuals tenfold, even more than that, actually. I mean, if you look at our game right now, it doesn't look bad, but it doesn't look very good. See, the problem with our game right now is it's got yellow on blue on green, and we've got red. It's just not a great color scheme. So I'm actually going to keep this as yellow because I think that the player looks nice, but I'm going to change a few of the other things, and I might change the tints of things. So to start, I'm going to make the background black because I think that will look quite cool. So I'm going to go ahead and drag that right to the bottom. Now we've got a black background. Now, the second thing I'm going to do is I'm going to go to the player and I'm going to make them slightly more bright, like that. I'm thinking that's looking good. Then I'm going to go to these floor pieces and I'm actually going to change their color to blue. So I'm going to go over here, let me open up the floor so I can see these changes take effect. I'm going to make it like a nice light-ish blue, like around there. I think that's pretty good. I'm going to copy that hexadecimal, just so I can put on the other two. Go to the environment, take both floors, and then pop that right in. I think that looks a lot better. And now the last thing I'm going to do is I'm going to go to the triangle and make it slightly more red. So there we go, that looks good. Now if we play our game, I think that is a very big visual improvement. We can see now it looks a lot better. It looks more like a actual arcade game, or like an old arcade game than what we had before, the weird color scheme. But we can actually make this a whole lot better with the use of post-processing. And if you haven't heard of it before, post-processing is basically these effects we can add visually to our game to make it look better. So I've gone ahead and created this post empty object, haven't added anything to it yet. Just make sure if you haven't done that already, I can delete mine to show you. I'm going to go create empty and I'm going to call it post processing. That's actually much better. Then let's center it in the middle, make sure everything's set to 0. And then I'm going to go into my window package manager and I'm actually going to add this post processing package. And this is going to allow me to do everything I want to do. So I'm going to click install and it's just going to take a while. Once it's done compiling scripts and everything, you will be able to start adding post-processing to your game. So there we go, quite quick. And then I'm going to click on my post-processing object and I'm going to go add, and I'm going to click a post-processing volume. So type post-process volume. Right, and now this is where we're going to actually create our post-processing effects. But before we do that, we need to add a layer to the camera, which basically enables it so that we can have post-processing. So I'm going to go post-processing again. You see I've got here post-process layer. And this is going to be the cool thing. We're going to go over here and we got our trigger. Now the layer is going to be set to nothing. So that's basically saying, okay, we can't have post-processing. If we set a layer here, we set what we want to be able to add post-processing. So I'm actually going to set to the water layer, not for any other reason other than we're not going to use the water layer. So that's kind of like a spare layer we have. So I'm going to make it water and leave everything else the same. Then I'm going to go to my post-processing and I'm going to change this layer over here to water, which is really cool. And now I'm going to tick this is global box and I'm going to go to profile and I'm going to click new. That's going to make a post-processing profile for us. And if we go into game, we'll be going to be able to see this in action. So I'm going to go here, add effect, Unity, and I'll click bloom. And this is going to be our first post-processing effect. If I increase the intensity here, you can kind of see what it does. Obviously that's a little much, but that's kind of the general effect of bloom. It adds this nice glow and you can see that's going to do wonders for our games. I'm going to make my bloom maybe something like, I think 5 is probably good. We have quite a nice neon theme going on, so it fits. I'm going to leave my threshold at 1 because I think that's actually fine. And all the other things I'm going to leave as they are because I think that's looking pretty good. I could, if I want to change the color to something like red, obviously, and then have a red glow or yellow if I wanted yellow glow and everything. That looks quite cool. Could also add maybe a green or like a blue, kind of like the blue one, but I'm going to leave it as white for now. I might add it to blue later, but I'll see. I think white looks good for now, so I'm going to uncheck that color. Then I'm going to add my second of my 3 effects I'm going to add a vignette effect. I don't know if I'm pronouncing that right. I'm going to go here to intensity, and I'm going to increase the intensity to about, you can see kind of what it's doing. That is a vignette or vignette effect. I'm going to make mine something like 0.3. So it's a little subtle, but you can kind of see it on the edges. If I made it 0.5, that would be a bit much, obviously. So 0.3, I think, is like a good middle point. And then the last effect I'm going to add is going to be color grading. This can be quite a complicated one, but don't worry, we're not going to be using all of these. We're just going to click over here, mode, and change this to low definition range. And then over here, our temperature we're going to leave, our tint we're going to leave, but we're actually going to make sure that the temperature is set to 0, which it is. Then we're going to go over here to these 3 bottom, and these are the ones we're going to be changed. Saturation, brightness, and contrast. I'm going to actually change this to 10, brightness to 10 as well. Then make sure my contrast is maybe 4. I can even add 10 as well, but I think that makes it look a little less nice. So let's make it 4 or even 3 would be better. And we can see now we have what I think is a million times better looking game. If I go ahead and hit play, I can see that this game, in my opinion, looks 10 times better than what it did. It now looks like an actual game. This actually looks a lot like one of the first games I ever made called Square Root. And yeah, that's kind of what I'm basing this course on. But yeah, you can see our game looks a lot better now. We've got like glow effects and we have all of the nice visuals that we added. We've got the better colors. I think that's looking pretty nice. Now, the last thing I want to do is add a death effect, and we're going to do that with a particle system. Now, this is going to make our game look a million times better. Trust me, there's going to be a nice effect when we die. It's going to be an explosion, then we're going to respawn. That's going to look really great. But before we do that, I'm going to want to go ahead and make sure we disable and enable my player sprite when I die, because that's actually the first step to this process. So I'm going to go over here to my state manager script. I'm going to open that up. I'm going to create a public sprite renderer and call it sprite. Then over here under my die void, I'm simply going to go underscore and say sprite.enabled equals false. And that basically means go to whatever sprite's attached to, which is going to be this player's sprite renderer. Go over here and disable it like that. So it's no longer going to be active. Everything else is obviously still going to work, but yeah. Then the second thing, I'm going to copy this code, and under respawn, I'm going to set that to be true right at the end. So basically, like we're doing with a lot of other stuff, like our gravity and everything else, we're just setting it to be something else after our state is changed, which is really cool. Now I just need to go to player and make sure that I've assigned my sprite renderer here. So I'm going to go to the top, and if I try and drag this down, it's not really going to let me. So instead, I'm just going to go over here and I'm going to click over there and select player, and that's going to give me the right one, which is the exact same thing as dragging it down. Obviously I couldn't because there was so much in the way. Now if I go and play my game, I can actually see this in action. So if I go and I'm playing and I run into a spike, my sprite will disappear and then I'll respawn. But that doesn't look very good. We want to add an effect, and we're going to do that with a particle system. So I'm going to go add component. I'm going to type in particle system. As soon as you've added your particle system, click on the player and click Shift H, which basically puts it in isolation view. So it's the only thing you can see, which is really, really useful for us. Then we're going to go ahead and we're going to start adding a particle system. Particle system is, I'm sure you can guess, it's a particle effect. And currently these are all the default settings, but we don't want those. So we're going to change ours up a bit. The first thing we're going to do is we're going to go to texture sheet animation. I'm going to go through every single step because this is quite a complicated component. It took me a very long time to get the hang of, but I've sort of got a partial knowledge of it now, enough to make a nice particle effect for our depth. So go to texture sheet animation, check it, and click on it, and then change this mode from grid to sprites. Then go into coarse assets and drag your square over there. And now we should almost be using our square. We just need to go to renderer and select the material as sprites default. And then we are using normal squares, right? Now go back here and we can see it's a looping effect, but we obviously don't want it to be looping because we want it to happen once. So uncheck looping. And then if we click restart, we can see this effect goes on for 5 seconds and then stops. And we can see it no longer going on. But we don't want it anywhere near. We want it to be like 0.2 seconds. That's going to be the duration of our explosion. And we also want there to be a lot faster. So we want our start lifetime to be something less like 0.8. Then we can see all our particles go and then go away. So that would be perfect, and then we'll respawn. Now we also want the speed to be a lot more. So let's change that to 10, and then the particles are going to be a lot faster, which is nice. And we want the size to be slightly bigger, so we're going to make it 1.5. Then we have these nice bigger particles, which is cool. Then over here under emission, this is where we're going to change a bunch of stuff. We're going to make this rate over time 100. We can see now that's slightly nicer, but it's actually not enough. So I'm going to make this 250. There we go. That's a nice amount of particles. We can even make it 300 if we want, but you don't have to. That's good. Now I'm going to go to shape, and actually my shape is a cone, which is perfect for this effect. So leave everything in there. Now I'm going to change 2 things. First of all, I want to change my speed over lifetime. So check that box and then open it up. Click on the size, and you're just going to click on this auto-generate graph over here. Then we can see speed of lifetime, they're going to get smaller as they go. You can also choose that one if you want. It's quite similar, but I find that for explosions, this one works slightly better. So that's cool. Then you can go ahead and go to color over lifetime, check it, click on color. Then you're going to want to go ahead and click at the end over here, this top one, make that 0. And that's basically going to give you a nice fadeaway effect, like so. Now, the last thing we need to do is actually make sure that the color of these is the same as the color that we're using. So click on the color, click on this fine tool, then just go ahead and choose somewhere on your square. You can see now it's going to look quite similar, which is nice. Now, there's a few changes we might find we need to make, but let's test this for now because it might work perfectly. To do that, obviously, we do need to code to say when we want to do the particle. So press Shift H again, back into our game. And we can see if we play it now, it is in front of the background, which is nice because our background is -10. If it wasn't, we could change a factor in here that would make it go in front, but it is, so that's fine. Then we're going to go into our script over here, still the state manager. We're going to create a public particle system like that, and I'll call mine PS. Then over here under my die, I'm just going to say right underneath my sprite label, I'm going to say ps.play. Then parentheses and semicolon. And what that's going to do is it's actually going to let me play this effect as long as I assign it. So I'm going to go here to my script and drag my particle system in there. I'm going to minimize that so you can see it. And now before we test it, let's just go ahead and make sure that we have unchecked play on awake, because otherwise it will play as soon as we start. Let's go and click it. And then we start, everything's fine. If we die, it should work. We can see there a very nice particle explosion fadeaway effect, which I think is pretty good at the moment. There are a few changes we can make. For example, I think that we need to have the color a little less so at the beginning. So let's make this alpha down to 150 under color over lifetime. And then the last thing I want to do, I want to actually add more. So I'm going to make this 500. And I'm also going to make this size slightly smaller. So I'm going to make it 1.2. See, that is going to be our new particle effect. We can also make it a little bit faster, in my opinion. Maybe make it 15. And there we go. That should be better. If we now start, we should see our particle effect in action. The minute we die, we can even fall down here and see it. And there we go. I think that's quite nice. Obviously, it was cut off screen, so let me show you how it looks like on a normal triangle. Over here. And there we are. I think that looks quite nice. Obviously, it could be improved. Maybe try playing around with it. See if you can get yours to look better than mine. But I think for now, that is exactly what I need. And the great news is, because of all our earlier work, making sure the player doesn't move, if we fall and die, like I'm trying to illustrate now, I'm just too good at our game, then it doesn't move, which is really, really cool. So hopefully after doing these, you have made some drastic visual upgrades to your game, and yours is looking a whole lot better. Just take a look at what our game looked like right at the beginning and look at it now. I think it looks a million times better. So great job, everyone. I think that these visual improvements make our game look a whole lot more professional, And we are once again getting closer and closer to our game being finished. So great job everyone, I'll see you in the next video. Hey there, and welcome back to Unity. Now, as I'm sure you remember, in our last episode, we heavily upgraded our game's visual component. But there's been one aspect of game development which we've been neglecting this entire time, and that is our game's sound design or audio component. Now, obviously, this breaks into two main categories, our game's music and our game's sound effects. And in this course, or rather this episode, we're going to be adding both of those things. Now, I am only going to be adding a sound effect for the jump and for the death animation, and only one music track. But if you want to, after you've done this video, you can go ham adding as many music tracks you want or extra sound effects, because you're going to be using the exact same process that I'm going to be using, so it'll be easy to expand. Now, to start this, I'm first going to make a music manager. So I'm going to right click here, create empty, and I'm going to name this music manager. Then I'm going to obviously center it, just like I always do. And then I am going to want to add my music manage script onto this. So I'm going to go create a new C# script, and I'm going to call this music manager. But it's actually going to be a sound manager. So you can name whatever you want. I'm just naming my music manager. Then I'm going to go ahead and open it. And the reason I'm naming it Music Manager is because that's obviously the first thing we're going to be adding. We're not going to be adding the sound yet. And then I'm going to create a reference to, and this is what we call an audio source. This is basically kind of Unity's way of saying an MP3 or WAV player. So I'm going to go public audio source, and I'm going to name mine AS, capital A, otherwise it's the word as, which is obviously restricted, so AS. Then I'm going to go ahead and create a public void, and I'm going to call it play. Make sure to not have it autofilter on player connect or on player disconnect. Then I'm going to go as dot play. And now this is basically going to show us how we can link audio sources. So if I go here, void start, and then over here, I'm going to call this play void. So in effect, I'm saying as play on start. Obviously, this is quite a tedious way to get there, which you might have noticed, but I'm just trying to illustrate something, so bear with me. Then over here, we need to create our audio source. So let's go ahead onto Music Manager, because we're obviously going to add the music there. We're going to go to Course Assets, and we're going to drag the music file in there. Now, this music file is a royalty-free song from the internet, but you can use whatever you want. Just make sure that you are not using music that is infringing on someone's copyright. Obviously, this is royalty-free. So go ahead and check this loop box, and then you're going to want to uncheck play on awake, because we're kind of manually doing that here. Obviously, we could just click play on awake, but like I said, I'm trying to illustrate something. Then set the volume something like 0.5 and the pitch to, I think, about 0.9. That's basically slowing the song down. I think it sounds better like this, but you don't have to. You can change the pitch to whatever you want, really. It goes up to 3 and down to -3. So I will change it to 0.5. I wouldn't recommend doing it, 0.9. I wouldn't recommend doing anything less than 0.4, otherwise it gets a little too slow. And then we're going to go into our Music Manager still, and we're going to add our Sound Manager script, or we'll call it Music Manager. We're going to drag our audio source in, and we can see we've unchecked play and awake, but as soon as we click play, our game is going to start playing music. Very, very cool. Now, we've got our music script, and you can obviously play around with that as long as you like. I have cut this specifically so it should loop, but if you want to make it so that you fade in or out or use a different track, you can obviously change all of that. Just change the audio file you're doing. All this is doing is playing one file and looping it. If you do change the music, make sure to readjust the pitch, otherwise it might be a bit slow for your taste, but right now everything is working perfectly fine. Now, the second thing we need to add is sound effects, and we're going to do those using audio sources. But the problem with using audio sources is that if you have multiple audio sources on one object, it gets a little hard to differentiate between them. So I'm actually going to store audio sources for the player, one on the player and one on another object. It doesn't really matter what I use. I could use the event system if I wanted, or the spawned floors object, which is obviously our storage space. It doesn't really matter. I'm going to put mine in the environment because that is one of the most useless objects, but even though this one doesn't move, it's still going to play the audio. It's not like the audio is affected by how far we are. So I'm going to go ahead and add an audio source. And we'll see we dragged it on last time. That's just a quicker way of doing it. And I'm going to add the die effect to this audio source. Then I'm going to make sure to uncheck play on awake. I'm going to make the volume also about 0.5. We might have to adjust these later, we'll see. Then I'm going to go to my player and I'm going to scroll into the bottom and add another audio source and add the jump effect. Once again, change the volume to 0.5 and changing the play and awake to false. Make sure that both play and awake and loop are set to false for this one. And then all I need to do is I need to go into my script and create new public voids for playing the other music. So I'll go public void and call this one play jump. And underneath I'll go public void play die. And these are basically going to be the two other audio sources. Then I'm going to go here and I'm going to create as jump and as die. And I'm going to rename this to as music so I can differentiate between it. I'm of course going to readjust that there. And then I'm going to copy this exact code, obviously just changing which audio source I'm playing. So over here, I'm going to go as jump.play. And over here, I'm going to go as die.play. Now, if you're noticing something, these procedures are quite similar. So we could actually, if we wanted to, use parameters and then just call one procedure. But I've often found that using parameters can give you a few issues in the Unity editor. And so for simplicity's sake, we're not going to do that. What I mean by issues in the Unity editor is because these scripts are being called by code, there would be no issue at all. But if we want to call the script via an object, so if we want to click a button and call a specific void, and we had too many parameters, sometimes it doesn't let us correctly reference it. So don't worry about that for now. It's not going to be an issue we're going to run into, but we could actually rewrite this as one procedure. I'm just choosing not to because this way it's a little easier to read. But if you notice that, great job. Now we just need to go into our state manager. We need to make sure we call the correct void. So we're going to go to our state manager and we're going to create a public music manager and we'll call it music. Then we're going to go down to this die void and we're going to make sure that we call it as soon as we die. So after the particle system, I'm going to go music dot play die. Perfect. And then over here, I'm going to copy this exact code. And we are also going to want to play this whenever we jump, but obviously that is not linked to the state manager, that's linked to movement. So we're going to do the exact same process. We're going to go public music manager, call it music. And then over here on the jump void, we're going to go music.play die, except this time we're going to want to play jump. So dot play jump. Now, there's a little bit of a signing we need to do before this works, but once we've done that, everything should work perfectly. Obviously, we've changed the movement script, the state manager script, and the music manager. So let's go and check all of those have everything assigned they should. First, we'll start with the movement script. It doesn't have a music manager, so make sure to drag that in. Neither does the state manager. And then under the music manager, we need to make sure we actually have the right audio sources. So drag as music over there, because we changed the name, it will reset, so make sure you do that. Drag the player has the jump, and the environment has the die void. And then I'm going to go ahead and play the game and you can see how this sounds. That was cool. We can see in that short amount of time, we've actually created a fully functioning audio system with music and sound. And the great thing about doing this, obviously we can see over here, we kind of have some pretty useless code. We're calling play from a start procedure, which is doing it on its own, which isn't very ideal. But the reason I wanted to do this is because now we have a link to our audio music. And later on, when we create our menu system, we're going to create functionality to mute all of these audio sources, and that's actually going to let us do that, which is really cool. So stay tuned for that. Good job, everyone. Hopefully everything works, and I will obviously link my code in the resources. If you want, you can change up these audio things to be whatever you want. Just drag your new file in there and it will update everything. And great job. I'll see you in the next video. Hey there, and welcome back to Unity. Now, obviously in the last episode, we added sound and music to our game for the very first time, making it feel a whole lot more responsive. We can see that here, just like we did in the last episode. Super cool. Now, while this is incredibly cool, some people might actually not want audio and sound just like we do. or I hope you do at least, because you've had to listen to it for the past episode and a half. So we're going to add a menu system that allows us to select whether to play sound or mute it, and also play the game, and it will take us back there when we die. And this is actually going to be quite simple. It's going to be probably one of the more complicated things we're going to do, probably the most complicated thing left to do in this course. Maybe you might find adding in ads a little bit confusing, but other than that, this menu system, it just takes some getting used to. But after that, you should be fine. So to start, we're going to first start by making a menu script. I'm going to call our script menu. Then I'm going to go ahead and double click this. And now, before I even start making my menu, I'm sure you can think we're going to want two different states. We're going to want a state where we're playing the game and we're showing the score on the high score text, and we're going to state where we are not showing the score on the high score text, which is cool. Exactly what we're going to fix. So over here, we're going to have a public void and call it show menu. And directly underneath that, we're going to have another public void and call it hide menu. And then what we're going to need to do, we're going to need to create a system where we can hide and show specific buttons and other UI elements based on what we want. So I'm going to go ahead and make that now. First of all, I need to actually start designing my menu. So I'm going to go over here to my UI, and I'm going to make sure to uncheck score and high score. So once this loads, I'm going to click on them like so, click uncheck so we can't see them anymore. And then I'm going to start building my menu. So I'm going to go right click, UI, and I'm going to create a button with Text Mesh Pro. Now this is going to go ahead and autofill. We obviously can't see because our post-processing layer is a little in the way, but if I go ahead and scale that up, we should be able to see our button, and it's glowing because of our post-processing. I actually can't really see with this in the way, and there's a cool way you can hide gizmos. If you go here to the top right, you can take away all the gizmos in the scene, which is pretty useful at the moment. So I'm going to go ahead and rename my button to play. Then I'm going to go here to the UI sprite. I'll go to course assets, and you'll see over here you have a play one. Make sure that all of these, just like we set the first three at the beginning to 1000 pixels per unit, make sure you do the same here, otherwise they're going to be very big. And then go to here to play. Once you've done that, drag it in, and power. We can see a rather disfigured play button. Then I'm going to go to text and delete it. And then I'm going to go here and set the native size. And here we have our play button, which is pretty cool. Obviously, it might be a little small, so I'm going to scale that up a bit. And then I'm going to set its position on the X and the Y to 0. Now, you might find that these position coordinates are a lot bigger. If we move this to 60, it only moves slightly to the left. But if we moved our player to position 60, you can see they go completely off screen. And the reason for that is because they're different coordinates. These are UI coordinates, and the other one are world coordinates. So just don't get confused there. If I set this to 60 and that to 60, it's not going to be the same thing. There is code that you can convert them, but we're not going to need to do that in this episode, so luckily for us. Then I'm going to go ahead and retoggle my gizmos so I can see them again. And I'm going to make sure to set that to 0 and move it down a little bit. And I think I want my play button to be the same color as the floor, so I'm going to go ahead and do that. I think that looks quite cool. Then I'm going to want to add in my play and sound option. So I'm going to do very similar. I'm going to go right click here and go UI button Text Mesh Pro and call this one sound. And over here, I'm going to make a new one and call it music. Sorry, my music and sound buttons. And then I'm going to go here and delete both the text objects attached to these. Move both of these over here to the top right corner. Don't worry about these arrows. That's just Unity working out how the buttons work. And I'm going to move the music down there. And then I'm going to go here and I'm going to drag music into music like I did with the play, sound into sound, and click set native size for both, just like I did. And then I'm obviously going to scale these down. So I'll make this about 0.4 and 0.4. That looks good to me. And the same for the sound one, which is cool. Now I just need to make sure they're at the exact same X position, so they're right underneath each other. And I think that looks pretty good. We now have our game with a menu system at the top right. And we can go ahead and change these to whatever. I think I'm going to change these colors. I'll see how it looks at yellow. Not great. I think I'm going to make them all blue, but you can actually make it whatever you want. If you find a shade of yellow that looks nice, or any other color, that will work perfectly. Then the last thing we need to do is we need to obviously create a title for our game. So I'm going to right click, I'm going to go UI, Text Mesh Pro, and rename this to title. Then I'm going to move this up. I'm going to obviously want to scale this a hell of a lot bigger, so I'll go like that. Make it maybe not that big, but big enough. Set the X position to 0, move the Y down, like so. And then I'm going to change some of the settings here. So first of all, I'm going to set the alignment to the center and the center, so it's right in the middle. Then I'm going to rename, I'm going to make sure that I have, before I rename actually, I'm going to make sure my font size is quite big. So I think maybe 150 or even 200, that's probably good. And we can see new text over there. I'm going to go ahead and actually move both of these slightly down again. Make sure the title and the play sound are both moved down, and we can see that looks a little better in my opinion. And then we obviously need to make it the same color so it fits. We could also change the font if we wanted. I obviously did not install that font pack, so I'm not going to be able to, but I'm going to leave mine as Arial for now. I'm going to name mine Cool Square. Now, if you can't come up with as brilliant a name as Cool Square, I don't blame you. You can name yours whatever you want. Cool Square is clearly the best name, but if you haven't been able to come up with something that good, don't feel bad for yourself. Not all of us are creative geniuses like myself. And after we've done that, our menu system is actually looking pretty complete, which is pretty cool. Now, all we need to do is actually program logic to these buttons, because if we hit play, obviously we need to set these active again, because that's actually how our game looks when we're playing it. We hit play, we don't want these buttons in the way, because, yeah, obvious reasons. Then I'm going to want to go ahead and program logic to these. So I'm going to go to my menu system over here, and I'm going to create a reference to every single one. Now, before you start, make sure you go to the top and write using UnityEngine.ui and using Text Mesh Pro, just like we did last time. And then I'm going to want to create a few objects. I go public Text Mesh Pro U GUI. We're going to call this title, because that's going to be our title. And then we're going to want to create a public button, and we're going to call this one play. We're going to call the next one music, and we're going to call the next one sound. Then we need to go over here to UI. I'm actually going to put my menu script right on UI, so just drag that there, and then make sure I assign all my things. So my play button to play, my sound button to sound, my music button to music, and my title there. And we're almost done. The last thing we need to do is we need to create a reference to the score and the high score. We're going to just add some commas and then put those right there when they load, put the score there and the high score there. Then what I need to do is I need to create logic for when I want to show which one. So obviously when I'm showing the menu, I want to make sure that everything except the title and the score is showing. Sorry, the score and the high score. And when I'm hiding the menu, I want to make sure the exact opposite. And I'm going to do this with parameters, because I know I've mentioned in the previous episode that sometimes Unity has weird things with parameters, but I've often found that that's actually only when you're using more than one parameter. So I'm going to call this from code, so it's going to be fine actually, but I'm going to go ahead and go here, and this is actually going to be a much better way to do it. I'm going to go public void change menu, and then I'm going to have a Boolean, and I'm going to call it X. And now from this, we can actually set every single one, because obviously we're going to want to set them to be completely contrasting. We want to set either all of these and neither of those, or both of those and neither of all the others. So I'm going to go to here, title dot game object, so I'm referencing the game object, dot set active, then open brackets, and then I'm obviously could enter X here. And then depending on what we enter for X, I would set the title active to that. And I'm going to basically make sure that I do this for every single one of them. So title.game object, I'm going to want to do the same for score, the same for high score, and we can actually copy lines of code by pressing Control D. That's quite useful. Then I can also do the same for play, for music, and for sound. And obviously this is going to set them all or nothing. And we don't want to do that. We want to set the score and the high score to be different. So I'm just going to put an exclamation mark right in front of that. And that's basically going to say not X. So the way this code works is I'm entering a Boolean X, either yes or no, true or false. And I'm going to call this void. If I want to hide everything except the score, I'd go change menu false. And then it's going to say, okay, set the title false, the score not false, so true, the high score not false, so true, and everything else false. And obviously if I do the opposite, it'll set this true, this true, this true, and these two false, which is really, really cool. It's a really simplified way of doing this. Then all I need to do is I need to create a reference to this menu from my state machine. So I'll go public menu, and I'm going to call it menu, so I have a link. And then I'm going to go over here to my divoid where I'm calling everything else, and I'm actually going to say menu.change menu, and I would of course enter true over here so that everything is set to true except the score and the high score. And then under the respawn void, I'm going to do a very similar thing. I'm going to go over here, under my thing and set menu to false. Now, what this is basically going to do is this is going to make sure that when we die, the menu shows and then it goes back. And that's not entirely what we want. I'll show you how that looks now. And if we go ahead and hit play, before we hit play, actually, we have to assign everything. So let's go to our state machine and make sure that we set our menu to menu. And then before I hit play, I'm actually going to mute the audio because I can talk over. So I'm going to go to my music manager and I'm going to go ahead and hit mute on the music. And then I'm going to do the same with the player. I'm just going to go here and click mute, and the same with the environment. So I'm not having any audio. If you don't want to do this, that's fine. I'm just so I can talk over. I'm not being overshadowed by the very cool soundtrack to our game. And then if I go ahead and hit play, this is actually pretty close to what I want. We can see everything showing at once. If I die, only the menu shows and then that shows. But obviously the menu's not very useful because even if we click something here, it doesn't really do anything, which isn't ideal. So I'm going to change this code logic a little bit. Instead of saying have a delay and then automatically respawn, I'm going to call this respawn void from the menu, and I'll show you how that looks. If I go ahead and comment this out so that all it's doing is waiting and then nothing happens. Of course, this is kind of useless code, but we're going to use it later, so don't delete it. Then I'm going to go over here to my play thing, and on button click, I'm going to click here and I'm going to drag in my player. I'm going to go no function. I'm going to go all the way down here to state manager and I'm going to click respawn. And what this is actually going to do is look pretty cool. We're going to see, obviously everything is right there when we start, which isn't exactly how we want it. But if we die, we don't respawn. And then if we want to click this, we do respawn. And that's actually pretty close to how we want our menu system to work, which is again, really, really cool. Now, there's a few issues. First of all, I want to make sure that these two are disabled when I start, because that's not how I want it at all. And the second thing I want to make sure that I have is I want to make sure the player is not actually in a moving state at the beginning of the game. So I'm going to stay in state manager and I'm going to set my state to idle at the beginning. It doesn't really matter what you put here because we're just checking if it's playing or not. So you could even put dead there. Doesn't really matter. And then the other thing I'm going to do is I'm going to set my gravity, obviously in my move, to 0. So we start by being suspended in midair, which is very similar to the death state without all the effects. So let's go back into Unity and we can see how this looks over here. If I start, I am suspended midair, and as soon as I click play, I spawn, which is really cool. If I die, I'm going to have that again and pop up and everything's working perfectly, which is really, really, really cool. Now, the few changes I want to make. First of all, I want to make it so that you go back to the beginning and you respawn even before you have all the other effects. So we are actually going to go back to that coroutine and we are going to put that respawn void back in here. But instead of making it one void, we're going to change it into two. So we're going to go public void and we're going to call this one start game. And this is going to handle all of the other logic except setting the position and setting the pretty much that. Go over here, we'll change that. And now what this is going to do is when we die, we're going to go back to the beginning, but we're not going to set anything else. And then we're going to change our button to call this void instead. So go over here to my button, UI, go down to the play button, and I'm going to go ahead and change that to state manager and start game. And that's pretty cool. Now, if I go ahead and play my game, I can click start the game, I can die, and then there's a delay and I go back. But I don't want my menu to show just yet either, so let's go back to our code and we're going to change that menu logic. Instead of changing the menu as soon as we die, I'm actually going to set it when we respawn, which is pretty cool. Now you'll see how this works in game. Go back to my game and we click over here. We can see we start with the menu, click play, we can play along, our high score is obviously saved as we did a while ago, then we respawn and it's back to the beginning, which is really cool. The last thing we need to change, we need to make sure these buttons actually work as well. So that's also going to be quite simple. We're just going to go into our menu script again, open it up, and we're going to make a new void and we're going to call it change audio. Public void, and we're going to call this change audio. The one's going to be change audio, and the other one is going to be called change music. And that is basically going to say whether we want to change the music or not. And we're going to do this to floats. So we'll go public boolean music and audio. And then all we're going to do over here is we are going to set them, change them. So we'll go music equals not music. And that basically just means if it's true, it makes it false. If it's false, it makes it true. Obviously, we're going to put that over there. And we're going to put the same over here for audio equals not audio. Then lastly, all we need to do is we need to have an access to our systems which can actually play these. So music manager. So I'm just going to go ahead and create a public music manager, call this music manage, and then I'm going to go music manage dot, and then I'm going to find the audio source I want. So if we go here, we can see that it was actually called as die, as jump, as music. So when I change my audio, I'm going to set as die and as jump, the muted, to be whatever our audio is. So I'll go dot muted equals, and then audio. And I'm going to copy this exact code and put that down here, except this time as jump. Then I'm going to do a very similar thing over there. I'm going to go down here and I'm going to set music dot as music equals, and then change it to music over there. And these 5 lines of code are actually going to make us have a very cool system which can alternate between muted and not muted audio. So we'll go back over here. Obviously, you do a little bit of assigning first. So let's go and make sure our music manager is linked there, and go to our sound thing and make sure it has an on-click event. Drag in the UI, click no function, click menu, and then select the one over here that says change audio, and go here, do the exact same with music, drag in your UI, menu, and this time change music. Now, before I play, I'm going to go ahead and make sure that I have actually unmuted all the things I muted earlier so that I can show it to you, because I don't want that to be messing with our game a little bit. So let's go ahead and unmute everything, and I will show you exactly how this works. We can see we can mute the audio with ease and unclick to carry on. We can also do the same with our sounds. If I go here, I can see that my player sound has actually been muted. If I unclick that, it has not. So I can play with just sound and no music. Very, very cool. Now, this is obviously the basics of our menu system. I think we've made some quite big leaps in our game. And this is the last big thing we need to add. The next episode, we're going to do monetization, and then it's just fixing up our game, and we are actually ready to port it to mobile. So great job, everyone. I hope you enjoyed the episode, and I'll see you in the next one. Hey there, and welcome back to Unity. Now, this is the last main feature we're going to add to our game. This is the last episode where I'm going to talk about a completely new feature we're adding, and that is monetization. After that, our mobile game is pretty much done. We just need to obviously port it to mobile and build it, and we can see everything will work perfectly fine, which is really, really great news. You've come a really, really long way in your mobile game development journey. So great job. You've done amazingly. Now, mobile games always use ads to monetize. That's a bit of an overstatement, but practically every single mobile game out there uses ads of some kind, because it's a really great way to monetize your games. And adding them is not super easy, but it's not actually as hard as you might think, thanks to Unity's ad package. Now, we're going to go through this process step by step. Be sure to follow everything I do, because making small changes can result in weird little things you have to do. So just make sure you follow everything exactly. So to start, go over to scripts, and you're going to want to import this ad manager script. Now, if you go to the resources of this video, you'll find that there is an ad manager script over there, and you can go ahead and actually download that, and that will give you the ad manager script. The reason I didn't include it in course assets is because it's going to give you errors as soon as you download it. It's going to say advertisement does not exist. That's completely fine. That's just because we haven't enabled ads on our game yet. So to do so, once you've installed that, and you probably do have your 2 errors there, go to Window, select General, and select Services. And once you've done that, you should see this thing. It'll take a while to load, and then you'll get these list of services. All of them should be off for now. So go to Ads, and you might not be taken to this screen right away. Now, the reason I was taken to this is because I'm obviously already signed into Unity, because I've used Unity before. But if this was the first Unity project you made, this whole mobile game, you might not be signed in. So it'll ask you to sign to your Unity account. Now, I'm assuming you do have a Unity account because you installed Unity Hub, and I believe you have to have a Unity account to create one. But if you did not, just go ahead and create one. It'll be a really simple process. You can obviously do it on unity.com and just make an account. Then once you've created your Unity account or your Unity Hub account, whatever you need, then just go ahead and it's going to ask you to create a ID for your game. So you're going to have to choose an organization, and you might be wondering what this is. If you go over here to dashboard, you click here, it's going to take you to your Unity dashboard. And this is actually going to be where you can control all sorts of stuff like that. Obviously, I haven't signed in yet, but if I were to sign in, it would then take me to a page where I am able to create organizations and such like that. So go ahead and make an organization if you haven't already. And then you're going to, if you might have to restart Unity, you're going to reload Unity, and the organization will be there as one of the drop-down options if you have to choose that to select your game. If you haven't run into any of these problems, don't worry. I'm just saying it in case anyone does. And then lastly, you'll have to say whether you are going to be targeting people under 13 or over, and that is so you are COPPA compliant. go ahead and click yes, just for good measure. Obviously, we don't know enough about copyright yet to be fully making that assumption. If you are planning on releasing a mobile game, I recommend you do some research on that, because that is a very important law you have to follow when making mobile games. It's obviously the Children's Online Privacy Protection Act. But if you are not, if you're just trying to finish this course and you'll get into that later, just go ahead and click yes or no. It doesn't really matter because we're not releasing a game at the moment. And then you'll be taken to this screen. Now, first of all, click on for ads, and that's going to take a while to load, and it's going to freeze maybe. It's going to load your thing, resolve packages, compile C# scripts, and after a while, it should enable everything, so ads is on. And there you are. Now we can see we have ads on. It says current version 3.7.5. Now this actually automatically installed onto Unity. I'm not entirely sure why. Mine automatically installed, but a previous time I was doing it, it didn't. So I'm not entirely sure how it works. I will show you how to install it in case yours hasn't, but if yours has installed to a current version and there's a later version available, make sure that you download the recommended version, not necessarily the latest version, because I found the latest version sometimes gives me issues. So if I want to make my game ready for ads, I need to download this package over here. Like I said, I've already got it, but go over here to Window Package Manager. If you don't, it's right there. And then find this advertisement one. And if you have not installed it, click install. Obviously I have, so I'm not going to remove it. And you'll also see that my errors have gone away, which means my ads are working perfectly. The last thing I want to do is click over here on ads, and I'm going to enable test mode because I want to make sure I'm not using real ads. If you're testing your game or you're the one playing it, you're not actually allowed to use real ads. You have to use test ads, which is exactly what I'm doing. Then I'm going to go ahead and I'm going to open up Ad Manager, and we can see all of these errors should actually go away as soon as it refreshes. If they don't, sometimes Unity does have issues with it. Like for example, mine aren't going away. If I close it and I restart it, they might go away, they might not. Unity's a little weird, and hopefully by the time you're using Unity, they'll have patched this. You can see now my errors seem to have gone away. Oh, no, they haven't. So I'm going to go here and I'm actually just going to go ads, and I'm going to turn it off and on. Now, it's important to keep in mind that these errors are not as a result of anything you're doing wrong. This is Unity, and they have this really annoying glitch. So just bear with me here. If it happens to you, just do what I'm doing. Either turn it off and on. We'll see if that works. We can see for me, it has in fact worked. So now it has worked just because I turn it off and on. You can see, obviously, I've done nothing wrong. There's nothing wrong with the script, just Unity's issue. If that doesn't work for you, you can also try uninstalling and reinstalling the package by going here to the Package Manager and then going there and removing and installing it. So yeah, hopefully now you should be at a point where your game has this script and no longer has errors. If you have, great. Now, the last thing we're going to do is we're just going to show an ad every single time we die. And that's actually really easy to do. Now, before I change that, I'm actually just realized that my class name is not the same as my file name, which is an error we talked about earlier. So let's go ahead and fix that. Otherwise, that's going to give us errors in the future. Make sure this is the same. By the time I've uploaded this course, yours should be updated, so don't worry. But if it's not, just make sure you have that. And that's for every single script. Now go over to State Manager, and we're going to create a new public ad manager. We'll call it add. Then over here, when we die, on top of all of this stuff, we're going to call our respawn void. And as soon as we respawn, underneath this respawn void, inside the coroutine, you're going to go add.showAd, parentheses. And this is basically meaning that every single time we die, we're going to see a short ad. Now, obviously, if this was our actual mobile game, that would be a little annoying. And I don't think it's fair to have our user watch one every single time. So instead, we're going to create an integer variable. We're going to go public int and call it add weight. Then instead of saying show ad, we're going to say add weight equals add weight plus 1. And that's basically a way of saying, okay, increase by 1. We could also write this as add weight plus equals 1. That means the exact same thing. And then we're going to say if add weight is greater than or equal to 3, then I want to reset add weight, so it's 0. And I want to go ahead and show my ad. And what this is going to do is this is going to mean every single time we die, we're going to increase ad weight. So every third game, we're going to show an ad, which is a little nicer. If we go ahead and go open Unity, we're going to link this and we're going to test if it works. So go over here to player. We'll find our state manager on there. Make sure you click back to inspector. But we haven't actually added our ads into our game yet. So we also need to create a new object. Let's go create object, call it ad manager, right next to music manager. Just center it, drag in your ad manager over there, then go to your player and make sure to drag that onto your state manager script like so. And if everything should work, we should be able to track ad weight over here. If we go ahead and hit play, we can see, just going to mute that for now and that over there. If I go ahead and hit play, you can see I die and my ad weight is now 1. If I go ahead and die again, my ad weight is equal to 2. And if I do it for a third time, what should happen is I'm actually shown, here we go, perfect. This is Unity's way of telling us that our ads are working. So if we were now to build this game and run it, we would actually have working ads, which is really, really great. Great job, everyone. That means that our final addition to our game is actually completed. This is our finished mobile game. It's incredibly impressive how much we've been able to do over such a short span of time. Great, great job. That's incredible, and you've done amazingly in this course. Well done to everyone, and after completing the final video following this, you'll have created your very first mobile game in Unity and C#. So, incredible job. Hey there, and welcome back to Unity for the last time. Now, you deserve a round of applause because you have created an incredible mobile game, and if it's your first mobile game or one of your first mobile games, you've done an amazing job. Great work. We're almost done with our mobile game, and there are a few things we need to change before we build it, and then I'm going to show you how to build it and test it on an emulator, or if you have an Android phone or an Android phone, if you build it for iOS, you can test it on one of their phones. I have an iOS phone, but I'm going to be showing how to build with an emulator. But before we get into that, I actually need to change one thing we did right at the beginning of the course. If you open up your movement script, you remember we were using keyboards, and the reason we were using keyboard shortcuts for our movement, or keyboard keys rather, was because we wanted to test it on our computer. So now we're going to go ahead and change that because we want to build it. So delete this and type input.touchCount greater than 0. And that's going to check every single frame that you are holding down if I'm ground and if you are jump. So you can hold down and continually jump, which is really cool. Now, obviously, we're not going to be able to test this because we can't jump. We can't touch our monitor because we're on a computer. And obviously, our UI elements actually work automatically with Unity. So then go to the top here, click Build Settings, and make sure you have your platform correct. I'm going to build for APKs. I'm not going to check that. And there are a few settings over here. You can set all sorts of things. You can set your resolution, whether you want to be able to have landscape right or left, all sorts of things. I'm going to leave those for now. I'm actually going to make sure I can only go landscape because I don't want our game to be portrait. The splash image you can add if you want. That's just like an image at the start. Other settings I'm going to leave for now. There are a few publishing settings, but this we can actually leave. We just need to go here. We need to click build, and we need to go ahead. This is where my project is stored on my computer. I'm going to go ahead, save, and it's going to start building. Now that's quite a lengthy process, so give it a minute. Once it's done building, your game will be exported. If you have run into any errors while trying to build your game, sometimes Unity does have errors that might not be your fault, maybe with the module you installed or anything like that. Just type them directly into Google, and I promise you there is most likely going to be someone there who's had the exact same issue you have and fixed it. I've done that countless times, and most of the time it has worked. So just try that out. That should fix up any problems you have that I have not encountered. Once that's finished building, you'll be all ready to test your mobile game. I build for Androids. I'm testing on the Nox Player Android emulator. You can, of course, use an Android or iOS phone if you didn't. And if you build for iOS, I believe you can download a Mac extension onto a MacBook to install and test mobile games from there. Now, before we test, there's a few things you have to note. First of all, depending on which platform you used, if you want to test your game like I am, you have to make sure you've set your game ID to the same one that your game was registered as, which I'm going to show you how to do now. All the ads won't work. So obviously, once you build your game, or before you build your game preferably, go over here to Services, click on Ads, and make sure that you have set whichever platform, either Android or iOS, this ID. Make sure you've set it over here to the string game ID in the Ad Manager. Go open up Ad Manager and make sure that you set it so that your string is that string of numbers. Once you've done that, ads should work perfectly in your game. The second thing to note is resolutions. Now, your game might work perfectly for your device, but there might be a few things that are slightly off your resolution. If this is the case, simply change your screen resolution in the Unity editor and move some things around. When I was testing this game, I had to move some things to the right, but overall everything worked perfectly and my resolution was pretty much fine. So if I go ahead and drag that into the Nox player, you can see it's going to install my game for me. Loading up, and it says install complete. I can then load up my game, turn up the volume so we can hear everything. And we can see it's working fine. That's great. If I go ahead and hit play, I can jump just like I have been, and I can hold down jump, and I'll keep jumping, which is really, really cool. If I die, I have that death effect, and I start over. I can turn off the music if I want, or turn off the sound and carry on moving. I obviously can keep going. And if I die 3 times, I'll show you in a second, I will see a Unity test ad, which is really, really cool. I can then go ahead and skip that once that's done and close it, and we can see I'm back to my game, which is really, really cool. That brings us to the end of this course. You have created your very first mobile game using Unity and C#. You've done an amazing job, and give yourself a pat on the back for making it all the way to the end of the course. You've learned invaluable skills of Unity and C#, and hopefully you've acquired enough knowledge to start making your very own mobile games now, or even improve the one we've made. I know for one we can use a better icon, so you can just go into your game settings over here, File, Build Settings, go to Player Settings, and over here you can select a new icon which you want. Obviously there are different ones, legacy, round, adaptive icons, you can choose ones over there. But obviously the Unity editor is now hopefully looking a lot more familiar, and the world of game development is now your oyster, especially mobile game development. Great job everyone. I want to thank you very much for taking my course. It's been a pleasure getting to teach you mobile game development, and hopefully you've had a fun time and learned a lot. You do of course have permission to use any of the resources in this course and anything that we've built to mold into your own mobile game. If you want to improve this and release it as your own mobile game, you can do exactly that. So great job everyone. It's been an amazing experience, and I hope it has been for you too. Thanks again for enrolling.